Welcome to Blismos Academy. Welcome to Python Beginners course on our YouTube channel. We hope this content helps you to get the basics of Python and inspire you to learn further. Important topics covered in this Python course are: we have provided the introduction to Python, then syntax in Python, then what are the important data types in Python, then operators in control flow, then loops in Python, then important functions in Python. In the end, we conclude the course with programs for you to practice Python. You may be wondering, where do you do the hands-on? You can do the hands-on either on Python terminal or Jupyter Notebook. We have installation video available in the installation playlist. Thank you for choosing us. Let us get started now.
Before we learn Python, we'll try to understand what is programming language, what are the different levels of the programming language, and what are the different types of the programming language. Let's get started. Before we really get into programming language, what is a language? Language is nothing but a system of communication used by a particular country or a community. For example, in case of USA and UK, people there talk English. In case of France, they talk French. In India, we do have multiple languages like Hindi, Kannada, Telugu, Tamil, Malayalam, and multiple languages are there. So a language is nothing but a system of communication used by a particular country or community. Now that we understood language, what is the language of electronic machines? What are electronic machines? Electronic machines can be a computer or mobile or anything which has machine. Now, we know that electronic machines are computer or mobile or the likes of that. How do they talk? What language they do understand? These machines can fundamentally understand only two instructions, that is 0 and 1, which is also called as a binary language. We are in a situation, all of us human or people talk a different language, and machines do talk in a different language like a 0 and 1, or they do understand a language that is a binary language, that is 0 and 1. Now if the communication has to happen between the people and the machine, what should be done? That is where programming language comes into picture. Programming language, in a layman terms, is a language to make connection between people and electronic machines. As we understand, machines cannot understand the language of the humans, and humans cannot understand the binary language. There should be something in between. That is where programming language comes into picture. We understood in a layman terms. How do we define the programming language? A programming language is nothing but a vocabulary or grammatical rules for instructing the computer or any computing device to perform specific tasks. As we said, we use machines to do some particular tasks, right? If you have to instruct them, we cannot use a different ways or different languages to instruct them to perform tasks. We have to use their vocabulary, and that vocabulary should be put in a certain grammatical context which is understood by the machines. That is what is the programming language. One more way of looking at the programming language is it's a formal language. which comprises of set of instructions that produces various kinds of output. Means you are trying to come out with a set of instructions that will take a input and processes the input and produces the various kinds of outputs. That is one more way of looking at the programming language. Now that we understood what is programming language, there are different levels of programming language. At a high level, we have two levels of programming language. One is high level. The second one is the low level. Low level language is more near to the machines. In this case, you can see it is more near to the hardware. High level language is more near to the people or humans. Low level language is a computer's own language and it contains 0 and 1, which is also called as a binary language. On the other hand, high level language is easy for the programmers to understand. Now that we understood the levels of programming language, there are different classifications of the programming language. One of the classification here is in terms of types of programming language. There are three types of programming language. One is a machine language. The second one is a assembly language. The third one is a high level language. Let us try to understand them one by one. What is machine language? Machine language is nothing but a binary code that can be directly executable by a computer's physical processor. When we write a machine code, that can be directly executed in a processor without any translation. And also the representation of a computer program which is read and understood by the computer. That is one more way of looking at the machine language. The last way is a program in machine code consists of sequence of machine instructions. As we know, machines wouldn't understand any other language. All the machine instructions should be in the binary code, that is 0 or 1. What instructions specify is instructions specify operations and memory cells involved in the operations. Memory cells come into picture where some data is stored. That is where the data need to be processed further. The next is assembly language. What is assembly language? It's almost like a human readable code. As we understand, machine language or machine code cannot be understood by humans. Assembly code or assembly language, it is a human readable code where there is a direct one-to-one analog with the machine instructions. Once we have a assembly code, that need to be converted into machine code by a utility program called assembler. When it comes to assembly language, each line of assembly code produces one instruction. That means, let us say you want to say hello. Hello would be saying 0 1 0 1 0 1. Some way it should be represented. That means each line, assuming that this is a assembly code, this would be translated into some machine code. What happens is when you want to program in an assembly language, it is slow and also there will be lot of errors, but it is efficient in terms of hardware performance. That is why we got to use the assembly language or assembly code. Now that we understood the machine language and the assembly language, what is high level language? High level language is a programming language that enables the programmer to write the programs that are independent of any particular type of computer. When it comes to the high level language, they're considered high level because mostly they are close to the human languages and very far from machine languages. Some of the examples of the high level languages are, we have Java, we have C++, we have Python, we have all these. These are the high level languages. This is one example of a Python code. We are storing two input numbers, num1, num2. We are using them and adding those two, and we are displaying them. This is the Python code, which is a high level language. Let us try to understand what are compilers and what are assemblers. Assuming that any humans write a program that is called as a source program. What happens is that would be converted into assembly language by a compiler. Then that code is taken by a assembler. That means assembly language is taken by assembler, that will be converted into the machine language. That is how whatever the code which you write, that would be converted into machine code by using a compiler and assembler. Talking about the compiler and assembler, we also got to understand how compiler based language is different from the interpreter based language. Compiler based languages use compiler. What compiler does? Compiler takes entire program and converts it into object code, which is stored in a file. On the other hand, interpreter directly executes the instruction written in a programming language. That is how the compiler differs from the interpreter. Languages which use the compiler are called as the compiler based languages. Languages which use the interpreter are called as the interpreter based languages. We'll try to understand this with an example. Assume we have a car owner. Car owner goes to a garage. Now, the situation here is, whatever the language spoken by a car owner, that cannot be understood by a mechanic. He's a wonderful mechanic, but problem is, whatever the language which is being spoken by a car owner is not understood by a mechanic. So then what is the solution? We need to bring someone in between. He can be called as a translator. We can do it in two ways. One way is, assume owner tells you something. Let us say you have to get done some 5 things on this car. One way of looking at it is, owner tells you something, first thing, this translator takes that and tells that to the mechanic. He completes that first tasks. Then next thing is, the owner tells the second task. This guy tells the same thing to the mechanic. He immediately acts on that, completes, and the same thing will continue until the 5th. So instead of owner telling all the things to be done at a time, what he does is he tells that one by one. This guy translates that into a language which is understood by a mechanic, and that will be done sequentially. This is how interpreter based languages work. They take instruction by instruction, and that will be executed then and there only. If you have 5 steps to be done, all of them will be interpreted individually and they would be executed. But on the other hand, the compiler based languages, what they do is, all the 5 things whatever need to be done would be given to this person. All of this will be converted to the language understood by the mechanic. Once this is done, even the compiler wouldn't be there. He will directly take all 5 of them and he will do those changes or repair in the car at a time. That is how the compiler differs from interpreter. In interpreter, code is executed instruction wise, but in case of compiler based languages, all the things what need to be done will be compiled first, and that will be converted into machine language, and that will be passed on to the machine. While the execution is happening, compiler wouldn't be there. But in case of interpreter, interpreter stays until the job is done, until the execution is complete. That is how interpreter based languages differ from the compiler based languages. So both of them come with pros and cons. In case of interpreter, it is slow, but the advantage is if there are any issues in the first instruction itself, will be able to immediately fix that. That is the advantage in the interpreter. On the other hand, the compiler based languages, initially they take time. They take time initially because the compilation is happening. But once the compilation happens, it is very fast. Compiler based languages are very fast. But if there are any mistakes, then it has to go through all the code again. That is also one of the cons on the compiler based languages. By the way, what is Python? Python is an interpreted high level general purpose programming language. Remember, interpreted high level and general purpose programming language. It is designed for ease of use with more focus on readability of codes. Somewhere in 1990, Guido van Rossum, who is a Dutch programmer, he is the one who created the Python programming language. Then, somewhere in 1994, we got the Python 1.0. Post that, somewhere in 2000 or so, we got Python 2.0. Now, somewhere around 2008, we got the Python 3.0. As of now, in the current 2021, we have 3.9.1 latest version of the Python which is being used. What are the features of the Python? Python, which is almost similar to the English language. There is a reason we say that, because if you look at the other languages like Java or C or C++, they're very syntactical, and means if you just miss a semicolon, the program or the code wouldn't run. But in case of Python, there are a lot of similarities from the English language, and also obviously any programming language has a mathematics influence. The Python also has an influence from the mathematics. As we already indicated, Python uses new lines to complete a command, as compared to the other programming languages like C and C++ or other languages which use semicolons or parentheses to complete the command. That makes the Python more user friendly. If you look at the other programming languages, they use curly braces to complete the scope of the code. Like the scope of the code can be a function, it can be a loop, but Python makes it simple. it relies on indentation. So you got to be really particular about the indentation, because Python is deciding the scope by indentation using the white space. So you got to be really careful with indentation. Let us look at what Python can do. Python can be used on server to create the web applications. As you know, there are programming languages specific to create the web applications. Python can also be used for creating the web applications. And Python can be used alongside any other software to create the workflows. As you know, there are different workflows as a part of the retail or a banking software or any of the other domains. Wherever the workflows are involved, Python can be used to create the workflows. The next thing is Python can be used for data science and machine learning as well, which is one of the very important technologies as a part of this whole 21st century. Then the Python can also be used for automation of the routine tasks. It may be testing or any tasks which are being done repeatedly. The same tasks which are done repeatedly, we can automate all those tasks by using the Python. We can also connect to database systems by using Python. It can read and modify the data within the database systems. Finally, since we are in a big data course, Python can also handle the big data and perform complex mathematical computations. Wonderful. Python can be used to create the web applications. It can be used to create the workflows, automate the routine tasks. Python is ubiquitous. When I say ubiquitous, it is there everywhere. So why do we need Python? I mean, why do we need to prefer Python over any other programming language? That is because, in addition to whatever we have discussed so far, Python can work on different platforms like Windows, Macintosh, Linux, even including the Raspberry Pi. Python syntax allows developers to write the programs with the fewer lines as compared to the other programming languages like C, C++, or Java. So it is easy to understand, it is easy to write, and also we can accomplish more by writing the few lines of codes. One of the aspects which we already discussed as a part of previous lecture is Python runs on an interpreter system. What it means is, as and when you are writing code, the code is being executed. That means we need not compile the program before we execute it. As and when you are writing, it is being executed. And one more last important aspect of the Python before we conclude on the introduction part, Python can be treated in a procedural way. It can be treated in an object oriented way or even a functional way. It's a kind of a combination of multiple things. So that makes the user to leverage the capabilities of the Python in the way he or she wants. Operating system on which we are working is Ubuntu. Depending upon which operating system working on, you can install these tools on that particular operating system. As I said, the operating system what we are working on is Ubuntu. To run the Python code, we will be using three things. One is the text editor like Atom. The second one is the Python package itself. The third one is Python IDE. Let us see them one by one. Atom is one of the popular text editor existing currently in the industry. There are many other text editors like Sublime Text and Notepad++ and all other text pads, but As I said, we are going to use Atom as a part of our practice in this course. To install Atom, open a terminal in Ubuntu and type in this command: sudo snap install atom hyphen classic. You are done. Atom will be installed. Then you can go and search in the applications, double click on atom icon, then text editor will open up for you. Next thing is installing the Python itself. Again, we are making it very easy for you. In a terminal, go ahead and type in sudo apt install python 3, because we're going to use a Python 3 version as a part of this course. With this command itself, you may get the Python 3 installed. And if you type a Python, you should get a Python terminal to execute the Python code. Just in case, if the Python is not installed, you can go ahead and install the pip package. Once you install the pip package, say pip3 install request, post that you can go ahead and install the sudo apt install python 3. In case this is not working, then only you should go to the installation of the pip package. Otherwise, no need to go there. That is how you install the Python. Again, there are multiple IDEs which are available in the market. We are going to use PyCharm IDE because it is wonderful in every respect. It has many essential tools for Python developers, and it is very convenient as compared to any other IDEs. Again, it is left to your choice to use which IDE you want, but as a part of our course here, we'll be using the PyCharm IDE. To install PyCharm IDE, open a terminal in Ubuntu and then go ahead and execute the command sudo snap install pycharm community classic. Post that, PyCharm gets installed, then you will get a PyCharm icon. You can double click on that and open the PyCharm IDE. First and foremost way of executing a Python code is on the command line. All you got to do is go ahead and invoke the terminal in Ubuntu and start typing the Python code. If you just enter, the Python code gets executed. That is one way of executing the Python code. One more way of executing the Python code is by creating a Python file. What you can do is you can go ahead and open any text editor like Atom and write the Python code in Atom. Save that as a .py extension and run that on the command line. That is one more way of executing the Python code. The next way of executing the Python code is by using any of the IDE. What you can do is, in this case, we invoke PyCharm, then create a project. Within that project, create a Python file and start writing and executing the Python code. These are the three ways of executing the Python code. Let us see them in action. We'll try the first scenario where we'll be invoking the Python and we'll start typing in the Python command line. So I will invoke the Python 3. All I have to do is you type the command or Python code which you want to execute. In this case, I want to execute a simple print command. Say hello world. If you hit enter, that gets executed because it's a interpreter based language. The next way is, once you double click on an Atom icon which is there as a part of your Ubuntu, after installation you'll get a interface like this. What you can do is you can just go ahead and say a new file and write a Python code. We'll try to write a same code, print Hello, I'm all. Save this with a .py extension. I saved this file with a .py extension. Let's go ahead and find this file in our terminal. There we have this Python ex1.py. All we got to do now is go ahead and provide Python. I'm giving Python 3 here because I do have both the version of Python 2 also 3 also. That is the reason to execute the Python 3 based code. I'm providing a Python 3 to execute the Python script. This is how that gets executed, and you can see, hello, I am all excited to be part of this course. The Python code gets executed. This is the second way of executing the Python code. How about the third way? We can use the IDE. In this case, PyCharm IDE. I double clicked on Python IDE. Okay, this is how you'll get file. Click on a file. Click on a new project and provide the name of the project as Python project for, in this case, demo. I'll click on create. So it is creating a virtual environment. It is getting all the packages into this project so that when we start writing the code, it automatically recognizes and auto completes some of the commands. It is indexing here, you can see. Yes. Now within this, right click on this project, go to new and create a Python file. You can see, click on a Python file. Provide the name of the Python file. Python file for demo. We're all set now. All we got to do is say print. The beauty here is all the syntax is highlighted and we are executing Python code part of ID. So if you go and click on this, run, you can see this gets executed. We are executing the Python code as part of IDE. When we executed the code in the previous lecture, in a way we already touched upon the syntax. Syntax with the Python is very, very simple. You can execute the code on any of the command line. We need not write many things as we do in either C or C++. Can directly go ahead and start executing the code or writing the code on any of the IDE or editor and execute that. Here in this case, we are trying to print and say hello Python, and also we have to include the string which we want to print as a part of the double quotes. This is the syntax to write a print statement, and once we execute this, we'll get a hello Python. Unlike other languages, Python indentation is important. We have already touched upon this, but we'll try to see it. As we have already discussed, indentation in Python refers to the spaces at the beginning of a code line. Other programming languages are using the indentation for readability only. But in case of Python, indentation is very important because Python uses the indentation to indicate the block of code. In case if you vary the indentation, inference of a block may change. That is the reason you should be very careful with the indentation in Python. Let us take an example here. Assuming that if 8 is greater than 2. After the if statement, we are giving a space and printing a statement. 8 is greater than 2. In case if you don't provide any space here, you may end up getting a error. So you got to be very careful with the indentation in Python. Do we have any common ways to identify? You have to be cognizant of the fact that what is the block, assuming that you are providing the if statement. Whatever the statements which come under if should be indented at the same space. After that, else at the same line as that of the if. Then again, statements under else should be indented at the same space as that of the statements under if. So that way, as and when you write a program, you should be cognizant of the fact that what are the blocks, what are the statements, and go on providing the indentation based on that. As and when you start practicing the Python, it is going to be intuitive for you. Next important aspect is Python comments. Why do we really need Python comments? First and foremost thing is comments are used to write something which programmer do not want to execute. If he doesn't want to execute, we can comment that. Second aspect is comments are used to make the code more understandable. For example, now we can say I am writing a function and comment so that readability of the code improves. The next aspect is comments can be used to prevent the execution while testing the code. Let us say you have three blocks: block 1, block 2, block 3. You already know that these two blocks are working, and these two blocks do not have any input to this. What you can do is you can comment these two blocks and go ahead and execute only block 3. We already in a way discussed comments can be used to make code more readable. If you put the comments properly, you will understand what is the reason you are executing this, where are you getting the input from, how the connection is there from this function to another function. So that way the code becomes more readable. In Python, we have two types of comments. One is a single line comment, the second one is a multi-line comment. To make any one line comment, we can use hash as the indicator to make any line as a comment. For example, in this case, this is a comment because we are using a hash as a part of this line. Multi-line comments are created by the multi-lines. So how do we do that? Basically, Python may not have a real syntax for the multi-line comments, but there is always a workaround. There are two ways you can approach the multi-line command. The one way is go ahead and have the hash in each of the lines. That is one way. The second way is what you can do is you can go ahead and provide the comments as a part of the triple quotes. Any line which is included as a part of the triple quotes, that will be treated as a comment. Why is that? That is because here the triple quotes are intended for denoting the string. If the string is not assigned to any variable, then what Python does is it ignores the string. It ignores the string and it will execute the other lines in the code. We will see how the indentation works and how the comment works by taking a couple of examples. Let us type code in Atom. Say if 8 is greater than 2, print 8 is greater than 2. Let's execute this. In this case, I have provided a indent. Fine, 8 is greater than 2. It works. Now, what we'll do is we'll meddle with this and see whether it works or not. I'll copy and paste the same thing And instead of providing the space in the print, I will take out that space. So let's go ahead and execute this. No, it complains. It says indentation error, expected an indented block. We need to be really careful about the indentation when you are writing a Python code, because in other programming languages we are able to differentiate between the blocks by braces and flower brackets and all those things. But here in Python, indentation is important. With the indentation, there will be a differentiation between the blocks. Let us take one more example. Let us take this. Now, so I'll say else. Else if 8 is greater than 2, and else, because else goes with if, both of them should be at the same level, same indentation, and print should be at the same indentation. So this should work. It works. Now what we'll do is, instead of else at the same level of if, we'll take out and move that to the this one. Let us see what happens. You can see, right? It complains. So indentation is important. We took a couple of examples and you are able to visualize how do we indent. Now that we have seen indentation examples, we'll go ahead and see the comment. We'll use the same code, simple code for the comment. Say we have seen for comment, we got to use the hash. So this is a comment. Awesome. Let's go ahead and execute this. You can see first line is a comment. What we have done is we have introduced a hash here. That is the reason this is neglected. This will not be included for interpretation. Now what we'll do is we have added a single line comment. Let us try to add multi-line comment. I'll copy and paste the same thing here. The second line, excuse me, comment. This also would work because we have added a hash to the second line as well. Both these lines are comments. It works. Wonderful. Now, how do we add more than 2 lines? If we have only 2 lines, we can go ahead and provide the hash. But if it is more than 2 lines, we cannot go on adding hash to each of the lines, right? So then what we can do is we can embrace this as a part of the triple quote. As we have understood, anything which is in the triple quotes which is not assigned to a variable, Python considers that as a comment. Let me go ahead and execute this. Okay, we have a multi-line comment here. We have embraced that in a triple quotes. It works. Wonderful. We have seen how the indentation works, how the single line comment works, and how the multi-line comment works. We can use all these things as a part of your Python coding in the upcoming classes. First of all, what is a variable? Variable is a name given to any storage area or memory location in a program. When we want to hold a value as a part of any of our code, that is where we define the variable, and variable is a name given to storage area. Let us say if you say x is equal to some value, so we are trying to allocate a storage area for this. That is what variable is. Coming to the Python variables are containers for storing the data values. Variable, as we have already discussed, is a container that contains some information. And whenever we need that information, we can access that. When we have to declare variables, we have certain rules. Let's discuss them one by one. These rules are pertinent to Python. Variable name can contain only the alphabets, digits, and underscore. For example, demo underscore XYZ, or you can say 234, something like that. It can have only alphabet, digits, and underscore. Any other values cannot be used to declare a variable. That is one of the first important rule. The next one is variable name can contain alphabets, digits, and underscores. There should not be any spaces. It is an extension of the first rule. There should not be any spaces. For example, now we have a demo underscore XYZ. Now we cannot say demo, then underscore XYZ, then this one. This is wrong. We cannot have spaces. The next rule would be variable name can only start with alphabet and underscore. It cannot start with any digit. 5 Harry is not allowed in Python. It can start only with either A or underscore, one of these things. It cannot start with digit. And also, no white space is allowed to be used inside a variable name. We cannot use a space between the different alphabets within the variable name. The last thing is we cannot use all these symbols. We can use only underscore, alphabets, and numbers. All these things cannot be used to define a variable. Let us understand how do we create the variables. Python as such do not have any command for declaring a variable. When you assign a value to a variable, that is when the variable is created. We do not explicitly define the variable as a part of the Python. As and when you assign a value, that is when variable gets created. For example, here x is equal to 5, y is equal to John. If you go and print x, it will print the 5. If you print y, it will print the John. Explicitly, we are not defining any variable here. We are assigning a value to a variable that gets created. Wonderful, isn't it? And also, one more very important aspect is usually in other programming languages, when we create the variable, we say x int, y char, and all those things. But when we use the variables as a part of the Python, we need not specify any type. Python has a capability to infer which data type this particular value belongs to. For example, here you can see 4 is assigned to a x. It will automatically infer x is of type int. In this case, when the same variable is assigned with a Sally, it automatically infers this is going to be string. That is the beauty of Python. And one more important thing is variable names are case sensitive. For example, here you can have lowercase a assigned with 4 and uppercase a assigned with some other value. In this case, uppercase a will not overwrite lowercase a. One more beauty here is Python allows us to assign values to multiple variables in one line. For example, here you can assign orange, banana, and cherry to XYZ in the same line. You need not go and have X is equal to orange, Y is equal to banana, Z is equal to cherry. We need not do that. If you say X, Y, X, comma, Y, comma, Z is equal to orange, banana, and cherry, all of them get assigned in a sequential order to these variables. Isn't it wonderful? And also, we can have one value to multiple variables. We assigned orange, banana, and cherry to different variables in the previous case. Here what we are doing is we assigned orange to all the variables. Just the opposite of what of the scenario what we discussed earlier. If you want to define a string variables, or if you want to declare a string variable, all you got to do is you can declare or assign a value by a double quotes or even single quotes. Both of these would be inferred as a string only by Python. When we talk about the variables, we often think about, is it a global variable? Is it a local variable? Let us try to understand what is the difference between global variable and local variable in the context of Python. Global variables are the variables that are created outside of a function. We are going to discuss the function, but since we are discussing the variables here, we are talking about the global and local. Whenever you define a function, any variable you are declaring or defining outside the function, that is known as a global variable. Since we are defining them or declaring them outside the function, they can be used by everyone, both inside the function also, outside the function also. It's a global variable. On the contrary, a variable that is declared inside a function or a loop is called as a local variable. Whenever we have a function, if we define the variable within a function, the scope of the variable is within that function only. It can be accessed within the function from the beginning of the function to the end of the function. The moment the function is done, will not be able to access the local variable outside that function. Wonderful, isn't it? One more thing what we often do is casting. What is casting, by the way? Casting is nothing but changing one data type of any variable to another data type. For example, int can be changed to string, vice versa. That is what casting is. How do we do that? As a part of the Python. So if you want to cast in Python, we can use it by a constructor function. Whatever the function which we use, that is a constructor function. In this case, when we use a constructor function, int, it constructs an integer number from either literal or float literal or even a string literal. If you see here, we are trying to say 1. So int 1, it becomes a 1. 2.8 of int, even though it is a float, this will round this off to the nearest value and it will store it as a 2. And in this case, if you see, 3 is given in a double quotes. What it means, it is ideally a string. Since we are using a int constructor, this will become 3. If you want to ensure float value to be assigned to variables, you can go ahead and use a float construct function. What it does is it constructs a float number from a either integer literal or a float literal or a string letter. The way we do it is x is equal to float and then say 1, it becomes a 1.0. And then this is float, it would remain the same. Since this is a string literal, this would become 3.4. Within the string, if you have a decimal, that would become a float. If you want to ensure that whatever the value you are giving is a string, you can go ahead and use a string constructor function. What it does is it constructs a string from a wide variety of data types, including strings, integer literals, float literals. First scenario, what we are saying is we can have a variable name which contains alphabet, digits, and underscores. Let us try this first. And I will open my Atom text editor. Demo underscore xyz is equal to, it's a string variable. Say print demo xyz. And let me go ahead and see if it works fine or not. We are assigning a variable. See here, this is absolutely fine. We defined a variable named demo underscore xyz. We assigned a string value into that and we printed that. It is working absolutely fine now. So what it means is the way we have defined the variable is fine. We have started with the alphabet and we have used the underscore also. Let us go to the next scenario. Variable name can contain alphabets, digit, and underscore. There should not be any spaces. Let us try modifying this and see if it works fine or not. What I will do is I will add a space here. I will try to execute this. See, it is complaining. So you can see it is a syntax error, invalid syntax, because we introduced a space here. We cannot have a variable name with space. Variable name can only start with an alphabet underscore. It cannot start with a digit. Let us try to modify this and see if we can have a digit also as a part of the variable. It will throw a similar error. I'll say 5. Again, it is complaining because we introduce a digit. The variable name should always start with an alphabet or underscore. We'll try by having a underscore instead of digit. It should work then. It is working fine now because any variable name can start with underscore. It can start with an alphabet, but it cannot start with a number. We have tried all the variations of variable now. One more important thing is we cannot use the symbols also as a part of the variable. Let us try introducing a symbol here. The same thing, I'll go ahead and say add, modify here also. It is complaining. We cannot use all these symbols as a part of the variable. Wonderful. Let us move on and look at the other aspects. Here you can see when we create a variable, we need not really declare them. So if you just assign a value, it automatically takes it as a variable. Let us go ahead and try this. So x is equal to 5. Y is equal to John and print x and print y. I'm giving this end of line because if I don't give that, I need to execute the last line. That is the reason. as a part of the Python command line. Can see we have assigned a value to a variable. We are printing them. It works perfectly fine. You need not declare them in isolation. And one more important thing is we can always change the value for the same variable. In this case, you can see we have assigned a 4 to the x and we are assigning a Sally to x. So in this case, the recent value will be printed. Let us go ahead and check this. I will reuse the same thing. X is equal to 5. Then now let me take out this. I am assigning a 5 in the first instance. In the second instance, I am assigning a John. When I print X, the recent value will be printed. You can see recent value is printed. John is printed here. And also, variable names are case sensitive. This is the lowercase, this is the uppercase. I am printing both of them. You can see both of them gets printed. And we can assign many values to multiple variables at the same time. Let us do that now. You can see here, I'm assigning all the values at the same time to these three variables instead of typing them in different line. Let us see how it works. You can see all of them gets assigned. And one more way of looking at is we can assign only one value to all the variables. We can do that as well. You can see same value is assigned to all these three variables. Orange is one variable, orange is one variable, orange is one variable. When you want to assign a string, either you are having a string as a part of the double quote or single quote, both of them will be treated as a string. You can see whether you are providing a single quote or double quote, both of them will be treated as strings. Now we'll look at the casting aspect. If you want to ensure a particular variable should be enforced to have a particular data type, then you can use these constructor functions. Let us see examples around that. Even though it is an integer, this will be treated as a number. If I assign 3 to this, and we can check the type of each of them, type of X, type of Y. You'll see the difference. Here I'm using a string construction method. You can see in case of X, since we are enforcing this particular number to be a string, it is saved as a string class. But in case of 3, we are leaving this to be inferred by a Python. It is taking it as a int. We'll see a couple of more examples. We'll see a float. You can see, since we are using a float constructor method here or function, this 3 is converted into class float. And also you can see, instead of printing only 3, it is printing 3.0. That means it is a float. But in case of y, it is printing also as a 3 and also it is taken as a int class. Okay, we'll see a couple of more examples. Now what we'll do is say 3.8 and make it as a int, opposite, just opposite. Okay, in this case we'll say 3.4. You can see, even though this is a 3.8, it is a float, it is printing it as a 3, and the class is also int. The data type of this x is also int. On the other hand, if you say y is equal to 3.0, it is taking it as a float, because since we are specifying it as a 3.0, it is inferring that as a float. All in all, the idea is, while assigning the values to the variables in Python, Python will infer the values depending upon the whether it is a int, float or string. Case if you want to enforce that a particular value should be of particular data type, then you can use the constructor functions like str, float and also int. Wonderful. Then we understood how to define the variables, what are the different rules while defining the variables by taking examples. We also understood how do we use the constructor methods for casting the variable for a data type which you want. What are data types? In any programming language, we do have data types. Whether you take C or C++ or Java, any programming language for that matter would have data type. Data type is a classification of data which tells the compiler or interpreter how the programmer intends to use the data. What it means is, let us say we have already gone through variables. If variable a is being assigned with a value 7, how does user or a developer wants to use this? He may want to use it as a integer, he wants to use it as a string, he may want to use it as a float. Data type classification is telling the compiler or interpreter. In this case, since we are studying the Python, it is telling the interpreter how the programmer wants to use the data. That is the data type. In Python, we have around 6 major categories of data types. Let us see them one by one. We have text data type. We have numeric data types. We have sequence types. We have mapping type. We have set type and we have Boolean types. These are the 6 major data type categories which are available in Python. Now, if you want to get the data types, I mean, if you have defined a variable and you have assigned particular value to that, if you want to know that particular variable is assigned with which particular data type, in that case we can use a type function. In our previous practicals, we have already used this function. So all you have to do is you have to use a type function and provide the variable for which you want to know the data type. It will give us the which kind of data type your variable is assigned with. One of the important data types are numeric types. There are three numeric types in Python. One is int, the second one is float, the third one is complex. When we say int, we are only assigning the integers like either 2 or 3 or 536 like that. When you say float, we have decimals like 23.5, 6.5. When you say complex, you may have 1j plus 0. Like that, complex numbers will be there. Python supports int, float, and complex numeric types. So how do we use the numeric types as a part of the Python? All you got to do is you have to assign a value to them. For example, here we are assigning 1 to x, 2.8 to y, and also 1j to z. Now, if you see, all we are doing is we are assigning a variable to them. So Python is inferring this x is having a numeric type of int. Because we have a decimal here, Python infers y is a float. Because we can see a complex 1j, Python infers, oh, this is a complex numeric type. Moving on to the text type. In text type, we have strings. The way we recognize or the way we have the strings in Python is surrounded by either a single quotation marks or double quotation mark. In this case, you can see hello, we are surrounding that by a single quotation mark. The same thing we are surrounding it by a double quotation mark. Both of them are same. How do we assign a string to a variable? Very simple. The way we assign a string to a variable is declare a variable, and whichever the string you want to assign, put that as a part of the double quote or even single quote, and have the equal sign in between a variable and value. You are done with assigning a string to a variable. Sometimes we know that some of the variables we have to have multi-lines. How do we go ahead and assign the multi-line values to a variable? Very simple. All you got to do is enclose the string whichever you want to assign to a variable with a triple quotes. You are done. One of the important aspect is strings in Python are arrays of bytes representing Unicode character. What does it mean? When you define a variable or you assign a string to a variable in Python, Python is treating those strings as an array of bytes. Python do not have a character data type. Even though if you go ahead and have a single character, it is treated as a string with a length of 1. If you want to access the elements of the string, you can use it by square brackets. Just to reiterate this point, we have a variable which is assigned with the string. Now, when we assign the string to a variable, this is treated as an array of H, E, L, L, O, W. When I say print A is 1, it will return H as an answer. We can also find the length of a string. The simple command len, L-E-N, len. If you provide an argument as any value, like a juice or an apple or whichever the string you want to get the length of, you can use the len function to do so. Moving on, we have a sequence types. Two important sequence types are lists and tuples. Lists, as the name itself suggests, it can hold variety of objects. To hold the variety of objects, we use square brackets here. And to separate the elements within the square brackets, we use the comma. We can use any elements here. When I say any elements, elements of any data types. You can use a string, you can use a int, and also you can use floats. Tuples are also sequence types. They are similar to lists, except two things. One is they use parenthesis or brace. In case of list, we had a square brackets, but in case of tuples, we'll use these braces, and also they're immutable. When we say immutable, once we assign the values to the tuples, if you want to reassign one more value to the one of the element or any of the elements, it wouldn't allow you to do so. That is why it is called as a immutable. Next type is dictionaries. This is one of the important data type in Python, which is being used in multiple places. Dictionaries are unordered mappings for storing the objects. Means you do not have any order here. As long as you have a key value pairs, you need not have any order. You can grab or retrieve any of the objects without having any indexing. You can get the values by keys. For example, if you see the dictionary market prices, we do have some three elements here. One is apple 80, it is a key, it's a value. Milk is a key, 20 is a value. Chocolate is key, 50 is a value. If you have gone through the map produce, that is also a key value pair. For distributed processing of the big data, we use MapReduce, which does the processing based on the key value pairs. We do have sets as one of the data types in Python. They are nothing but unordered collection of unique elements. You cannot have a duplicates as a part of sets. One of the beauty here is you can go on adding characters to the set. But as we already know, set itself is a collection of unique elements. We have to add only the unique elements. Then only it will allow us to add those elements into set by using a add method. Next data type is booleans. Booleans, most of us know, if you already know any of the programming language, they represent either true or false. Why do we really need Booleans? If you look at any of the programming language, we usually use the expressions. Expressions either evaluate true or false. Based on an expression evaluating to true or false, we will get one of the answers. And also, when you compare the two values, expression will be evaluated to true or false. Based on that, we'll get an answer or some result. For example, here we have assigned a value of 200 to variable A, and we have assigned a number 33 to variable B. In case B is greater than A, print B is greater than A. In this case, it is evaluating to true. If it is evaluating to true, then only print this. In case if it evaluates to false, that is when this action need to be taken. And that's it. Just to summarize, we have around 6 categories: numeric types, text types, sequence types, mapping, sets, and booleans. Within numeric types, we have integers, floatings, and also complex. Integers are represented by int, floating is represented by float, and as you know, numbers are integers, numbers with decimal point are float, and string is a ordered sequence of the characters, and list is the ordered sequence of the objects. Tuples are almost same as that of list except they're immutable. And mapping dictionaries are unordered key value pairs. Sets is an unordered collection of the unique objects. And finally, booleans are indicating true or false. We'll deepen our understanding by taking examples for each of the data types. First thing is a numeric types. As we understand here, all we have to do is we have to assign a number to a variable. Then depending upon the number, whether it is an int or float or complex type. Remember, to check the type, all we have to do is use the type function. Let's see some examples. Here I am going to assign one value to x and one more value to y. And let us go ahead and accept. You can see we just assigned value to a variable. In this case, 8 is assigned to x. You can see that is a int. When we get the type of this variable, this is an int. Then we assign 3.0 to y, that is a float. And we assigned 1j to z, that is a complex data type. So these are the different numeric types. Let us see some of the string types. All we got to do is we need to take any string and include the string as a part of the double quote and assign that to a variable. That becomes a string. I'll use the same thing here. You can see we included a string in double quotes, assign that to a variable x, and we can print that. You can see if you check the type of this variable, it is a string. that is string data type. Let's go ahead and assign this to variable. Done. If you just go ahead and type print this variable, it does print all this. This is how we can assign a multi-line string to a variable. Now, as we discussed, strings in Python are arrays. Each of these character are in a way representing the Unicode characters. This whole string is saved as a array of bytes. If you want to retrieve the characters out of this string, you can do so. Say print. You can see it prints the character here. This whole string is assigned to a variable, and this whole string is an array of bytes. We can retrieve each character by using a variable and providing the place of the character you want to retrieve. We can go ahead and get the length of any string. Either you can get a length of a variable itself, or you can directly go ahead and get the length of a string. There you go. We got a length of a variable itself, and we directly typed the string as a part of the length function, and we got the length of that particular string. Now we'll see examples around lists and tuples. As we have already seen, lists are the collection of objects. Okay, these are mutable. We can change the list. On the other hand, we cannot change the tuples. Let us see both of them now. I will go ahead and say my list is equal to this is the list. Now what we can do is, if you want to update a one of the element in the list, we can do so. It's updated. Let us go ahead and define the tuples now. Tuples are same except that we have to include these values in these braces, simple brace. Now I'll say instead of my list, I'll say my tuple. Let's go ahead and define this. There you go. Now let us try to update this and see what happens. We have already seen tuples are immutable. If you go and try to update this guy with something other value, you can see it will not allow us to do so. Tuples are almost like lists except that they are immutable. We have seen the examples of lists and tuples. Now let us look into example of mapping type, that is dictionaries. Dictionaries are also widely used these days in Python. You can see we created a dictionary. This dictionary has three key value pairs. One is apple 120, banana 50, orange 65. In case you want to retrieve the value for a particular key, we can do that. The way we can do it is provide the name of the dictionary and provide the name of the key for which you want to retrieve the value. Yeah, you can see for apple, our value is 120. In the same way, we can get for banana as well. Like this, we can define the dictionaries and retrieve the values corresponding to particular keys. In the end, we'll see the booleans. For boolean, we need to come out with the some condition. Let us go ahead and say A is around 200, B is 33, and if B is greater than A, it will print B is greater than A, else it will print B is not greater than A. We'll go ahead and define this condition and see how the booleans work. So we assign the values to A and B. Let's go ahead and check this statement now. This is how the booleans work. We have come up with a statement. If B is greater than A, then this statement is true. Then it will print B is greater than A. Else, this statement will be false. B is not greater than A. In that case, it will go ahead and print the else statement. That is, B is smaller than A. That is how booleans work. Working as a part of any of the IT project, when you are using any of the programming language like C, C++, Java, or Python, we would have operations. Operations to do multiple things. What operations would depend on the kind of project or type of project. But it is very essential to do operations as a part of any of the IT project. When we want to do operations, we need operators. That is where operators come into picture. What are operators? Operators are used to perform operations on variables and values. For example, here plus is an operator. It is doing an operation on 10 plus 5. It is directly doing an operation on value. This is value 1 and this is value 2. The way other languages have operators, Python do have operators. Operator types in Python are, we have arithmetic operators, we have assignment operators, we have comparison operators, we have logical operators, we have identity operators, membership operators. Finally, we have bitwise operators. As we have indicated in the beginning of the course, we will not be dwelling deep into each and every aspect of the Python programming language as a part of this course. We'll be looking at the different aspects of the Python at a very high level. We are just introducing the Python programming language to all of you. Considering that point, we are introducing these operators to you at a very high level so that you got to know what are the different operators which are present in the Python, and we'll take a couple of examples to show how operators work. Let us get started with arithmetic operators. When I say arithmetic, we are talking about addition, we are talking about subtraction, multiplication, division, and so on. Arithmetic operators are used with the numeric values to perform mathematical operations. It doesn't make sense to work on strings by using a arithmetic operators. So arithmetic operators are used with numeric values to perform common mathematical operations. If you look at the example here, plus is an operator here, and we can do operations on either variables or values itself. In this case, we are doing an operation on variables x plus 5. Depending upon the value assigned to these variables, we'll get a result. Or in the previous case, we can go ahead and say 2 plus 5 on a Python terminal. We'll get a addition of these two numbers as 7. Moving on with the assignment operators. What are assignment operators? Arithmetic operators are very simple. Even we have heard about arithmetics, and we would have practiced arithmetic during our elementary school. But what are assignment operators? Assignment operators are used to assign values to variables. As we know, we have already understood what are variables. When we define the variables, we need to have value assigned to those variables to operate on, or to be used as a part of the programming language. That is where assignment operators come into picture. For example, we have equals. This is one of the assignment operator. The way we use it is we are assigning 5 to x by using this assignment operator. And when we think about assignment operators, equals will be on the top of our head. But there are other assignment operators also. For example, you can see plus equal to. What it essentially means is x is equal to x plus 3. And same is the case here. We have minus equals to. What it means is when we have a variable and have 3, that means x is equal to x minus 3. If you want to take this example further, assuming that x is equal to 5, when we say x plus is equal to 3, that means x is equal to x plus 3. That means x is equal to 5 plus 3. That is x is equal to 8. That is how assignment operators work. When you're working as a part of any of the IT projects, we need to have a comparison between different values. For example, in a retail project, we may have to compare the sales of one day with another day. Like this, there'll be number of opportunities for comparison between the values, variables, and many aspects. That is where comparison operators would come into picture. Comparison operators are used to compare two values. It is as simple as that. What are the comparison operators? We have equal. Here you see equal, equal to, equal to. There are two equals. You should not get confused with the assignment operator and comparison operator. In assignment operator, one equal is assigning. Here we have two of them, that is equal. Here when you say x, y, that means to say that this variable is equal to this variable. X is equal to y. And in the similar way, we have not equal to, greater than, less than, greater than or equal to. There are some scenarios where you got to check whether a particular value is greater than or equal to another variable. In those cases, we can use greater than or equal to, less than or equal to. It is getting interesting, right? Let's move on. And we have logical operators. What are logical operators? Logical operators are used to combine the conditional statements. What does it mean? Sometimes we do have a requirement where we need to combine couple of logical statements. For example, in this case, we want to combine x is less than 5 and x is less than 10. Only when these two conditions are satisfied, that is when we want to make the whole statement as a true, or the whole statement has passed. So whenever there is an opportunity, whenever there is a requirement to combine the statements, that is when use the logical operators. We have and, we have or, we have not. And means both the conditions need to be satisfied. Or means any one of these statements are true, the whole statement would be regarded as true. And not is almost opposite to this and. In this case, if you see, it will reverse the result. Returns false if the result is true. In this case, if both of them are true, then it says no, 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 it is false. Moving on with the identity operators. What are identity operators? Sometimes we have a requirement to compare the objects. When we say objects, what does it mean? When we declare a variable, what happens is, as a part of the Python programming language, there will be memory allocated to that. It happens whenever you declare the variables. Now, whenever there is a requirement to compare the objects based on the memory location, when you say comparing the objects, you are in a way comparing the memory locations. That is when we use the identity operators. Is not. These are the two identity operators which are available in Python. In case of is, it returns true if both variables are of the same object. In case of is not, it returns true if both variables are not the same object. We do have membership operators. What are membership operators? Membership operators are used to test if a sequence is presented in an object or not. What does it mean? Sometimes you do have a requirement where you have a sequence. Within that, you want to check whether a particular value is present in that or not. For example, assuming that y is some string. So you want to check whether x is present in that string or not. In that case, we can go and use the membership operators. It returns true if a sequence with a specified value is present in the object or not. Not in returns true if a sequence with the specified value is not present in the object. It is just opposite of the in. In the end, we'll understand what are bitwise operators. Bitwise operators are used to compare binary numbers. What does it mean? What happens is, all of us use decimal system, or most of us use decimal numbering system. What does it mean? Let us say 46. That means it is 4t plus 6. That means it is 6 into 1 and 4 into 10. This is what the decimal system is. But there are some instances where programmers has to get into the binary computations. Instead of looking at the decimal system, all we have to do is 0 and 1. By using the 0 and 1, we can construct the numbers. Whenever we want to drill down to the operations on binary numbers, that is when we got to use the bitwise operators. Mostly as a high level programmers, we wouldn't be doing this, but you should know there is something called bitwise operator in case you may end up working in a project which will drill down to the binary numbers. Wonderful, then we understood about the different operators available as a part of the Python. As a part of our practical class, we'll take examples for each of these different types of operators and see how they work. First and foremost thing is arithmetic operators. Let us go on taking example for addition, subtraction, multiplication, division, modulus, exponentiation, and also floor division. I am there in Python terminal. We'll get started with the addition. Let us try to add your favorite number. We have 4 plus 6 is equal to 10. Let's take some big numbers and see if it works. Yes, it does work. Let us take example for subtraction. We are subtracting 5 from 9, we get 4. Let us try to subtract minus 1000, we get 2000. So we are seeing different examples of arithmetic operators. We have seen addition and we have seen subtraction. What is the next? We'll see the multiplication. 6 into 4 is 24. Let us go for some big number. 4, we have 3120. And let's go for division as well. Let's say 8 by 2. You can see 4. 8000 by 100, get 80. We have seen important arithmetic operators like addition, subtraction, multiplication, and also division as a part of the Python. Couple of other things are exponential, modulus, and also floor division. Let us see all of them. As we know, modulus will give us a reminder. 6 modulus 3, reminder is 0. 10 modulus 2, we have 0. 11 modulus 2, we have 1 as a reminder. So let us say 67 modulus 10, we get 7 as a reminder. This is how it works. Let's take some examples for exponential. 2, you can see 2 to the power of 2 is 4. Let's say 2 to the power of 3, it is 8. You can see 2 to the power of 4 is going to be 16. Let us take some other number. The power of 4 is 256. So we are multiplying 4 times. That is the reason we got result as 256. This is how you use the exponential. Now, one more thing called floor division. Floor division is indicated by 2 slashes. Floor division is almost like a division, except that even though we get a decimals and all those things, it will return to us the highest possible integer after dividing from some number. If I go ahead and say 2 to 2, the highest possible integer is 3. It will not give us the float, it will give us the integer, because 7 by 2 is almost 3.5. It is neglecting the 0.5 to give us the highest integer which is coming out of the division. Let's take some other example. Highest possible integer 8. Wonderful. We have seen all the important arithmetic operators. Next thing is assignment operators. We are assigning values to the variables and using those variables in our calculations. Let's see how to do that. Now let us assign x is equal to 2. Let us use this as a part of our calculation. So we'll say 2 plus x. It's going to be 4. It is getting the value for the x from already assigned value. Okay, because we already assigned it. You can do all the things from assign values. Let us say x will assign some bigger value. Now if I say x minus 10, give 10, 20. X minus 10, it will give us 10 as the result. So we have seen addition and we have seen subtraction. We can also see x by 10, that also gives us 2. You can also multiply. You can see x into 3 is 60. Wonderful. We'll see some other examples like floor division and also modulus, also exponential also. X modulus 5 is 0 because we have 20 as the number which is assigned to the x. If you go ahead and say 7, it should give us the 6 because 20 by 7 is 7 twos are 14. So 20 minus 14 is 6. That is how it works. You can also 20 to the power of 2 is 400. Wonderful. This is how you are using the assignment operators. So when you assign a value to the variable, that will hold good, and you can utilize the same variables across different computations. Let us look at the comparison operators. Equal, not equal, greater than, less than, and all those things. We will continue with the same. So if you say x is equal to 5, it says false. That is because x is assigned with the value 20. We can test all these things. X is not equal to 5, x is greater than 5, x is less than 5, and all these things you can try. Yes, x is more than 5 because 20 is more than 5. And let's see, we'll just go with also. You can also combine these two things. It is less than or equal to 5. If I say x is more than or equal to 5, this is a syntax error. The way we should use this is it's true. Okay, these are the different ways you can use the comparison operators. We can use some logical operators, like we can have two variables and you can combine them like and, or, and not. Let's go ahead and see that how it works. As of now, if you see the value of the x is 20, we are constructing the statement where we are saying x is less than 10 and x is more than 11. Here x is not less than 10, x is more than 10, right? Let us change this and see what happens. Now it is true because we have used x is more than 10 and x is more than 11. In both the cases it is true. Let us try to update the above statement with R. In this case it is true because one of these statements should be true, then only this will become true. Let us go ahead and update this. It will be false because x is not less than 10, x is not greater than 21. That is the reason it is coming as a false. We can use not and see how it works. This is coming as true because both of these statements are not right. That's the reason it is coming as a true. If I go ahead and update this as 11, it will come as false because one of these statements is not true, one of these statement is true. We don't want both of these statements to be true. That is the reason we're using a not here. Wonderful. We have looked at the comparison operators. We can use the identity operators. Is not. X is 6, that is false. That's true. X is not 6. X is not 20. If I say, then it will become false because x is 20. So we can use x is 20. It will give us the wonderful. We have seen most of the important operators we would be using as a part of the Python program. In real life scenarios, often we face different situations. For example, if you go to a retail shop, you would be presented with the different choices. Intuitively, you decide which one to select, which one to drop, depending upon your requirement, budgetary constraints, and all those things. As we know, programming languages are here to help human beings to take decisions, to analyze. Programming languages do have something called control flow structures to help to decide on the workflow, decide on the flow of any business processes. Let us try to understand control flow structures in Python. First of all, what is control flow? Control flow is the order in which computer executes statements in a script. As we know, we do have scripts. Within the scripts, we do have statements. Let us say 1, 2, 3, 4, 5. These are the statements. Now, how these statements need to be executed is decided by the control flow. It is the order in which the computer executes the statements. And also, other way of looking at is control flow is the order in which individual statements, instructions, or function calls of an imperative program executed or evaluated. Evaluation also comes into picture here. That is the control flow. In Python, we do have three types of control structures or control flows. They are sequential, selection, repetition. We'll see them one by one. What is sequential control structures? Whenever we execute statements one after another in a order, that is a sequential control structure. Here we have a block of code wherein one after another lines of code are executed. Nothing great about it, yet it is important to know there are sequential structure. Here you can see this block of code is executed, after that this, after that this. That is how the sequential control structures work. The second control structure is selection. In selection, we use it for the decisions, branching, or choosing between two or more alternative paths. As we already indicated, we often left with choices. It is not always everything is a straight path. We have to take a decision between few things depending upon the situation. For example, when you go for a college admission, the cutoff would be 75%. Any student who has scored more than 75% would be selected. Anyone who is less than that wouldn't be selected. That is one of the example of selection. We have some statements like if else, and switch, which will be used for the selection within the Python programming. The next one is repetition. What happens in the repetition is until and unless some condition is met, we need to iterate through the code. We have to repeat a piece of code multiple times until a particular condition is true or sometimes false as well. Some of the control structures in repetition are for and while. The selection is for decisions, branching, whenever we need to choose between two or more alternative paths. That is when selection will come into picture. Let us take a couple of examples. In the retail sector, like Walmart or more in case of India, there is a situation where if the price of any commodity or product is more than some $50, you can provide a discount of some 5%. If not, then you can go for a discount of some 2%. Assuming that in a banking sector, a person is applying for a home loan. In that case, home loan would be provided if the salary of a person is more than 50,000 rupees per month. But that will not be the only condition. Another condition should be in last 5 years you would have filed the income tax returns. Provided these two conditions are met, provide the loan. If not, no loan. So this is one of the example in banking sector. If you go on looking at the different sectors, we often provided with the different options based on conditions. That is where selection as a part of the control flow comes into picture. But one of the important aspect what I'm mentioning is conditions, right? What are the conditions which are supported by Python? Python supports the logical conditions from mathematics, like equals, not equals, less than, more than, less than or equal to, greater than or equal to. As I indicated, we are often presented with the conditions. Based on particular condition, we take decisions. As a part of the selection, we have if else statement or if else control flow structure. To use this, we need to have a if statement. If statement is written by using a if keyword. If keyword is needed to be used. So as we have already known by this time, we can say if B is greater than A, then print B is greater than A. We are trying to have a condition here. Based on the condition, we are letting the code do something. Means if the condition is satisfied, do something. If the condition is not satisfied, do something else. That is how it works. Else is a keyword which is part of the if else statement. Whenever there is a condition which is specified by a if, that doesn't happen, else will come into picture. It catches anything which is not caught by the preceding conditions of if. That is how the else works. For example, here A is equal to 200, B is equal to 33. If B is greater than A, then this statement will be executed. If B is less than A, then else statement will be executed. That is how if else works. Sometimes it so happens that you have to test the multiple conditions. It is not always that we will be presented with the only two conditions, right? As we discussed in a banking example, loan need to be provided in case certain conditions are met, like salary should be more than 50,000 rupees, last 5 years they would have filed the income tax returns, so on and so forth. Now in that case, we may need to have a multiple conditions. In that case, we can use a else if, which is also called as ELIF. If the previous conditions were not true, then try these conditions. That is where else if comes into picture. Sometimes it so happens that you have to go on testing multiple conditions. Like in this case, we want to check if the number is greater than 10, if the number is greater than 20, and we want to check couple of more conditions as well. In that case, we can go ahead and nest the ifs. This is also called as nested if. That provision is also there as a part of the Python. Whenever you want your if condition to be empty. Mostly you wouldn't do that. In case if there is any requirement, if you want if statement to do nothing, in that case we have pass keyword, so that pass statements will avoid getting any error when we execute the code. We understood how if else statements work. We'll take a couple of examples and see how do they work. First, I will declare a couple of variables and assign some values to them. Two variables are declared and we have assigned values to them. And we are checking if b is greater than a, print b is greater than a with just a if statement. Because b is not greater than a, it is not printing anything. We'll reverse it. Now, what we'll do is instead of now you can see b is greater than a. We have to change this statement also. Let's do that so that it is appropriate. Now we have changed this from b is greater than a to a is greater than b, and we have changed a is greater than b here to be printed. Let's execute this and see how it works. Now you can see a is greater than b. It gets printed. Whenever if statement is true, this is a condition. If this condition is true, it will print or it will do whatever is specified below that condition. If it is not true, then it will exit. It will not do anything. What we can do is we can convert this statement into if else statement. In either case, we need to know what is happening. Else. We'll execute this. In this case, if statement is not read, that is the reason it will go to else statement. It will go ahead and print the logic or statement which is mentioned as a part of the else logic. So this is how if and else statements work. Now we'll see how else if also works. So we executed this statement if print b is greater than a, else if a is equal to b, then print b and a are equal. In this case, why are we not getting results? That is because we have not even run this assignment. Let's go ahead and do that now. Now let's execute this. We are trying to check for else if. You can see b and a are equal. This is how you include the else if as a part of the if. I mean, after if, you can go ahead and say else if as well. It all depends on the project and what you are trying to do to use the if else statements. And one more example, what we can see is how do you nest the ifs? We can go for a nested ifs. We'll see how it works. You can see here we assigned 41 to one variable and we are having two ifs. One if nested with another if. If x is greater than 10, print it's above 10. If x is greater than 20, print above 20 also. There are some instances where two conditions may be true, right? In those cases, you can go for a nested ifs. Otherwise, you can have a else statement coming into picture and print but not above. Since both of these statements are true, it is only printing these two. In case If these two statements are not true, it will come to the else. Python control structures. As a part of a Python control structures, we have sequential, selection, and repetition. We already have gone through if else statements as a part of the selection. As a part of this lecture, we'll understand repetition control structures in detail. As we already understand, repetition is used for looping. Whenever we have a requirement to repeat a piece of code multiple times, that is when we'll use the repetition. In repetition, we have loops. Within that loops, we have first one being the for loop. What is for loop doing? For loop is mainly used for executing the statements or a sequence. When I say sequence, if you remember a list, we have already discussed about a list, right? In list, there'll be items 1, 2, 3, 4, or it may be A, B, C, D. If I want to iterate through all the elements of the list, that is when for loop comes into picture. Let us take an example. Here, if you see, fruits is the list, and we have elements like apple, banana, and cherry. If you want to print all of them, then we can use the for loop and provide a variable called x, provide the name of the list, and go on saying print. This will print apple, banana, and cherry. Let us try to understand this in bit more detail. Oh, why can't we print all of them one by one? Let us say one way of printing them is print apple, banana, and print cherry. We can do this way also, right? Why do we really need to use for loop here? We have only 3 elements as a part of fruits. That is a list. What if you have 100 elements as a part of the list? Will you go on typing print, print, print for 100 times? It doesn't make any sense, right? That is when we use the for loops. We can iterate through all the elements of the list and do something. In this case, we are saying print. What may be the real life examples? Let us say you are working in some digital marketing company. If you have to send the same email to some 1,000 participants, in that case, you have a list of customers' email ID. Email ID 1, 2, 3, 4, 5. We can go ahead and use the for loop as a part of your code. That is one of the real life example. Sometimes it so happens that you want to go through a list, yet when you find something, then you want to stop. That is when break statement come into picture. Break statement, what it does, it breaks the loop before it has looped through all the items. Why do we really need that? In this case, we are taking an example of apple, banana, cherry being elements of the fruits list. When we find the banana, break it. What may be the real life example here? Real life example is, let us say you are browsing through a list of books in a library. It may be a digital library. Library literally has some 10,000 books. Now you are looking for your favorite book. Favorite may be anything. It may be fiction, non-fiction, any favorite book you are searching for. What happens is your favorite book may be 100th or 1000th or even 9,000. It may be there as a part of the list as a 100th item or 1000th item or 9,000th item. But The requirement is you got to find the book. The moment you find the book, rest of the books doesn't matter to you at this point of time. That is when we use a combination of a for and break. In this case, assuming that it is a list of books, and in this case it is your favorite book. The moment it finds your favorite book, it breaks. Sometimes there may be a situation you want to iterate through the different elements in a list or a range in this case, and the moment that is done, you want to know whether the task is done or not. That is when we can use for and else in combination. So it will go through all the elements and print. The moment it is done, it will get into the else and it will say, hey, it is finally finished. That is how you use else with the for loop. Sometimes in real life situations, you may want to iterate through different lists. The condition would be there is a loop at a high level. For example, here we have a adjective as red, big, tasty, and we have fruits as one of the list. I want to iterate through both the lists. In that case, we can have a nested loop. As we have already seen nested ifs, in the same way, we are nesting this loop within this loop. Wonderful. We understood how for loops work. This is the while loop now. How does while loop differ from for loop? Loop is a loop, right? Why do we need for loop? Why do we need while loop? Very simple. If you remember, we just discussed for loops are for iterating sequence of statements or sequence. On the other hand, while loops are for conditions. Whenever you want to use while loop, there should be a condition around that. Whenever there is a condition, you want to iterate through some of the elements, that is when you got to use the while loop. So while loop, we can execute the statements as long as the condition is true. In this case, while I is less than 6, print I. So this is the condition here. Until this condition is true, this gets executed. Here, print I. And one more very important aspect in while loop is whenever you are iterating through different elements or a range of a particular list or something, you got to initiate the counter. This is a counter. Here in this case, counter is initiated to 1. When it comes to this, while I is less than 6, yes, 1 is less than 6, this gets printed. Then we are incrementing the counter. Then the value of I would be 2. Is 2 is less than 6? Yes. Print. Then it will become 3. Then it will become 5. Until 5, this gets iterated. The moment it becomes 6, what happens is 6 is not less than 6, right? 6 is equal to 6. That is when it comes out of the loop. That is how while loops work. As we already understood, there is a need to break the for loop. In the same way, there is also a need to break the while loop as well. There are conditions when you are searching for something as a part of the list. The moment you find something, you got to break that. That is when we use the break statement. Here, this is a condition. In case of for loop, we had a sequence or a list. And in case of for loop also, we had a condition to break. Here also we have a condition to break this. The moment this condition is true, break this. Awesome, isn't it? Now, there are instances where you have a loop where you want to stop the current iteration and then you got to continue the next. That is when you got to use the continue statement as a part of the loop. As we have used the else statement with for loop, in the same way, we can use the else statement with while loop as well. We can run a block of code once the condition is no longer true. Here in this case, what we are doing is while I is less than 6, then the moment this comes out of this loop, we can say this condition is no longer true. That is the reason it came out of the loop. Wonderful. We understood at a high level how does the for loop work, how does the while loop works. We'll see both of them as a part of our practicals. First, we'll go ahead and create the list because we need a list to iterate through for loop. Let us create the same list. Fruits is equal to, we created the list. Let's go ahead and run this. Lists are ready for us to iterate through. Then how do we write a for loop? Very simple. Simple, right? For all the elements in this list, I want to iterate through each one of them and print them. The way we are doing it is for it is a loop. X, we are using a variable X in fruits. For the first time, X is equal to banana. After that, X will be cherry. After that, X will be mango. For loop iterates through fruits list and it does the logic which is written below this. In this case, we are just printing them. Wonderful. Next, we'll try to understand how do we go ahead and break this in case we do have some condition where we have to break it. As we know, in the list we have three things: banana, cherry, and mango. As a part of this syntax, you can see we are saying please break this loop as soon as we encounter cherry. That is what is happening here. As soon as cherry is encountered as a part of this iteration, a loop is broken. It is not continuing to the next element. Depending upon the project, you can use the break inside the for loop. We'll use else along with the for now. Now you can see once the iteration of all the elements in a list is done, it will get into else and it will print whatever we have mentioned here. So after the iteration is done, we can mention a else statement and give the logic which need to be executed after the for loop. We will see nested for loops. The way we have seen nesting ifs, in the same way we'll see nesting the for loops. How do we do it? Very simple. For nesting loops, we need to create one more list. We'll go ahead and create this list. It's done. There you go. What we did is we are nesting the for loop. One for loop within another for loop. Here, adjective list has red, yellow, green. Fruits list has banana, cherry, mango. What we want to do as a part of this nested loops is I want to iterate through one element of this with all the elements of fruits. That way you can see red banana, red cherry, red mango. One of the element of adjective is getting iterated through all the elements of another list. This is how you use nested for loops. Wonderful. We'll see some examples in while loop as well. This is the code for while loop. As we indicated, we need to initiate the counter. Here I is equal to 1. We are saying initially to start with the value of the I would be 1. Then the condition is while I is less than 6, keep on printing the values of I. Here we are incrementing the counter. For the first time I is equal to 1. The next time I is equal to 2. Then it will continue until it comes out of the loop. When will it come out of the loop? When value of I is less than 6. The moment value of the I becomes 6, that is when it comes out of the loop. Let us go and execute this. You can see it has printed 1, 2, 3, 4, 5 because initial value of the I is 1, that gets printed. Then the value of the I becomes 2, that gets printed till I is less than 6. The moment I becomes 6, 6 is not less than 6, right? 6 is equal to 6. That is when it comes out of the loop. Wonderful, isn't it? Now we'll see how do we introduce the break statement within the while loop. You can see what we have done is we have introduced the break statement as a part of the while loop. If you see in the earlier case, it printed until the number 5. But now we are introducing a one more condition within the while condition. As soon as you hit 3, break this loop itself. That is the reason the moment it hits 3, it is breaking the loop itself and it prints only the values until 3. We'll see the last scenario, how to introduce else statement within the while. It's very simple. This is how we introduce else statement within the while loop. What we are doing here is after the loop is done with the iteration, then it has to get into the else and it should do whatever is mentioned as a part of the else condition. That is how you can see 1, 2, 3, 4, 5 is printed, and also we have a message saying the job is finished, which is included as a part of else. First of all, what is a function? Function is nothing but a block of code which runs when it is called. What do I mean by that? So far, have we not written any block of codes? Yes, we have. For example, in the previous lectures, we have understood about loops and also if else statements. Haven't we written a block of code there? Yes, we have written. But in that case, if you have observed, when we run that code, it just runs. But on the other hand, when we use a function, it's a block of code. It runs only when it is called. That is making a difference. What we can do is we can pass the data, which are also called as arguments or parameters into function. Once we pass those arguments into the function, depending upon what you have specified to be done, function will take those arguments and process that data the way you want, whatever the code you have specified under the function name. I hope it's clear now. Why do we really need function? When we can do the things sequentially, the way we had done in a while loop, in if else statements, why do we really need a function? Function is needed for different reasons. Let us say you want to do any repetitive task. Or you want to have any code which need to be used multiple times as a part of your whole application. That is when function comes into picture. That is one of the important reason. The second thing is, when you have a block of code named as a function, then testing will be easy. Two primary reasons being, whenever you want to reuse the statements you have written in a different part of your code, then it is better to have a function in a way that helps in better testing and better modularization of the code. These are the reasons for which we need to have a function. How do we create a function? Very simple. We can create a function by a keyword def, def, and we can provide the name of the function after that, and then you have to provide a two braces. Then you have to specify a colon, and under that you can mention the statements. These statements being whatever you want to get this function to do. We'll take one more example. The example being, you want to add two numbers. Addition is something which will be used across the application, right? Instead of you writing the same code again and again, you can go for a defining a addition function. The way we can do it is def, then provide the name of the function as add. This is the name of the function. Open a brace. Since you need two numbers to be added, and you will not be adding the same numbers again and again, right? For that you need to pass the parameters or arguments. Here we are passing x and y. Then we have to specify the colon. After that, provide a statement what need to be done. In this case, c is equal to x plus y. Go ahead and say print c. Wonderful, isn't it? Next time, all you have to do is add and say 5 comma 6. It will print the value. When you call this function with the arguments, it will give the result as 11. And you can call that function again. You can call that function as many number of times as you want. Let us say 4 comma 6. You can give it 10, and you can call for a bigger numbers also. That is the beauty of the function. So whenever you want to do something repetitively and you want to modularize your code, better to include the statements into a block and make a function out of it. Call it as many number of times as you want. As I said in the beginning itself, the function will not execute until you call it. How do you call a function? It's very simple. All you have to do is you have to take the name of the function and go ahead and call it. We'll see it as a part of the practical. It will be a bit more intuitive. As we already discussed, we can pass the arguments into the function. When we say arguments, as we discussed already in our previous example, if you want to have the two numbers added, you can pass the arguments. These are the arguments. Arguments are specified after the function name inside the parenthesis. This is the parenthesis. And it is up to you to add as many arguments as you want. Here we are taking one more example. This is the keyword. This is the name of the function, and this is an argument. We are passing only one argument, which is also called as a parameter. And then this is the statement, what you want to get the execution done. What you can do is, this can be replaced by Emil, Tobias, Linus. Wonderful, isn't it? Sometimes it so happens that you don't know how many arguments you pass. In that case, what you can do is you can add star arguments as a part of your function. So that way, whatever the item you want to access from that function, you can easily do that when you execute the function. In this case, instead of just providing the kits, I am providing it as a star kits, and then my statement would be the youngest child is kids 2. What it does is it will print youngest kid being Linus, because in this tuple what we are having is it is a 0, 1, 2. It will print the Linus. It will say the youngest child is Linus. While defining the function, sometimes we do provide a default value. For example, in this case, we are providing the country name as Norway. What it means is either I can pass an argument that will be taken. In case if you are not passing any argument like this in the third line, it will take the default value as a Norway. This is the default parameter value. Also, you can pass either string or a number or a list or dictionary as a parameters to the function. It will be treated in the same data type inside the function. So there is no different treatment for the different types of data. Just to take an example here, what we are doing is this is our argument or parameter. And remember, we are putting our for loop into use here. For x in food, print x. So our list is fruits. Within that, we have 1, 2, and 3. Now, when I call this function with this value, it will go ahead and print all these fruits. So that way, even though I am passing only the fruits as an argument, Python has a intelligence to decipher, oh, okay, this is a list. I need to print them one by one. That is how you can pass a list as an argument. Sometimes it so happens that we don't want something to be done as a part of the function itself. Means we don't want to print the value. We don't want the printing to be done as a part of the function. We just want a value to be returned so that we can use that as a part of the code which we are writing after that. In that case, what we can do is we can use a return. Instead of specifying complete execution including the print, all we want here is we want the value to be returned so that you can use it in the upcoming code. The last thing before we wind up this lecture, Python also accepts the function recursion. What does it mean? Recursion in a mathematical programming concept is a function calling itself. You can see it right here. A function is calling itself, that is called as a recursion. This definitely has a benefit so that we can loop through the functionality one after the other. But you got to be very careful here. If you use the recursion without proper knowledge, without properly taking care of when it has to be broken, then you may end up having the code running for infinity and causing the crashing of the application. So you got to be careful while using the recursion. Let us take an example here. Look at this. We are defining a function called try recursion, and again within this function we are calling the same function. That is where we are calling it as a recursive function. We are passing on a value assuming that we have passed a 6. So what exactly happens here is for the first time the value of the k is 1. Here we are saying 1 is greater than 0. Okay, then it will become 1. Then plus 1 minus 1 is 0. That means the first value will be 1. Next is 2. Right? It will come here. Oh, 2 is greater than 0. Then it will become 2. Then plus 2 minus 1 is equal to 1. 2 plus 1 is equal to 3. Then it will become 3. Like that, it will go on recursing until it hits 6. Wonderful then. We'll see all these examples as a part of our practical class. We'll take examples as a part of the practical class and deepen our understanding. First and foremost thing is, let's go ahead and define a simple function. I defined a function. The name of the function is my function. I opened the braces and I gave the colon, and below that I have given a print statement. Let's go ahead and execute this in Python terminal. Done. Hey, nothing is happening here. Why nothing is happening here? When we executed the if statement, when we executed the while loops, we used to get the results immediately. Nothing is happening here. Do you guys remember? What we discussed is we have to call the function to get the statements executed. Let's go ahead and call the function now. Very simple. Now you can see hello from function. So we defined a function and we called a function. When we called a function, what are the statements which is there within the function that gets executed? As a part of this function, we have not specified or we have not passed any arguments. Let us pass an argument and see how it works. All I will do is I will take this function and modify this. I am passing an argument called variable. You can pass any argument, any variable. You can pass x, you can pass y. Now I will alter this print statement. Let's go ahead and execute this function with a variable and see how it behaves. It's done. Now, while calling this function, we got to pass the argument. What we'll do here is we defined a function with a variable. Variable here is an argument or we are passing a parameter. As we have already understood, we got to call the function. But while calling the function, we need to provide the value. Here, all we are trying to do is hello plus variable. As a part of this function, you got to pass a value. Here, I am passing Leonardo. When I execute this, it say hello Leonardo. This is how you write a function by passing an argument. We'll see how to pass a default parameter, and also when we pass a default parameter, if we don't provide any value while calling a function, then how the function behaves. Let's see that example now. Now we executed this function. Let's go ahead and say my underscore function. It says hello Raj. Then let us change this to Rani. It says hello Rani. If I don't give any value while calling the function, it takes the default value, default parameter, whatever you have passed on. We can also pass a list as an argument. How do we do it? Let's take an example. First of all, let's go ahead and define a list called fruits. See, we are using whatever we have learned in the previous lectures. We are defining a list here. As you know, we can create a list by giving the variable name in the square braces. So the first one being let's go ahead and create this. We have learned as a part of our loops, how do we iterate through the list? We need to use that also here. Let me define a function. We need to specify a colon here. As we have already seen, after for, because it's a loop, then go ahead and provide the what you need to do. print, I'll say x. Let's go ahead and execute this function. Let's call this function now. You can see all the values, all the elements in the fruits list are printed by this function. When we call this function by taking value as fruits. Wonderful. What if we don't want to print? We just want to return the value. In that case, we can use the return. It's simple. Let's go ahead and reuse this function. Instead of print, go ahead and use the return statement. As a part of the return, you can specify some logic also. That's it. Let's go ahead and we are done. So my function, let's give your favorite number. At the moment, let's go ahead and give 2. It gives this value. That is how we can use a return as a part of your function. To wrap up this practical, let's see how we can use the recursion. This is where we are recursing a function. We are all set to execute this function. Let's go ahead and execute. Hopefully there are no indentation errors. If they are, we'll fix that. This is how the recursion function is defined. If you see what is happening here is we are calling a try recursion function as a part of the try recursion function itself. Let us try to execute this with one value. Try recursion, that's a 6 here. Now it is giving a value 21. Why is that? For the first time, the value of m is set to 6. 6 is greater than 0. Then 6 plus 6 minus 1. It will be 5. Now, until the value of this m becomes 0, it will go on iterating and adding the value of m to whatever is being returned here. So that way, it will iterate through the value until the final value becomes 0. As soon as it becomes 0, then m is not greater than 0, it will come out of the loop. This is how the recursion function works, where we are including one function as a part of the same function itself, which is called as a recursive function. Whenever you want to write a program for any requirement, you got to understand what exactly is that requirement, what exactly is that problem. In this case, we are saying we are writing a program for swapping of the number. So what is swapping? Swapping in general is exchanging something. You can see in this picture, they are exchanging a video game with a tool. Then what is swapping in case of Python? In case of Python, swapping is nothing but mutually exchanging the values of the variables. We are exchanging the values of the variables. For example, we have 23 and 32, assuming that A is 23 and B is 32. If I want to swap, if I want to exchange the values of A and B, we can do that. Then B becomes 32, A becomes 23. So we want to swap the numbers by writing a Python program. Before you write a program, you need to have some thought process. You need to have some logic created. Then go ahead and start writing a program. First, you understood what is the problem statement, or what is the problem, or what is the requirement. Then you go ahead and come out with the logical diagram or logical representation of solving this problem. People do that in a different ways. I am depicting this in a flowchart. When you say you want to write a Python program, first and foremost thing is you need to define the variables. Okay, in this case we are talking about two numbers. We want to swap the two numbers, right? So we have input 1, then we have another input. Then go ahead and swap them. You have value 1, value 2, that becomes value 2 and value 1. This is what we want to do. Okay, so then after you reassign, you swap the numbers by some logic which we will understand while writing the program. Then you print the values. That is when the numbers get swapped. Let us get straight to Jupyter Notebook and start writing this program. I am in a Ubuntu. Within that, I have opened a Jupyter Notebook, which is opened in a browser. So here I will go ahead and click a new and say Python 3. It is IPY kernel. I'll open this. Then I will get a notebook with a cell. So what do I need to do first? I'm writing a Python program here. Let me not go on defining the structure and all those things. Let me get straight to writing the program. Let me say Python program for swapping the numbers. So here, first and foremost thing is defining the variables, right? I will say A is equal to some 10. And I'll say B is equal to 20. Am I explicitly defining the variables? No, I am assigning the values to the variables. As a part of that only, variables are getting defined. That is the beauty of Python. You need not explicitly define the variables, then assign the values to that. When you are assigning the values, automatically variables are declared. Now, just to understand what is the value of these variables, I will say print values of the A and B before swapping. What are the values of the way? I will say comma A comma B. Okay, let me run this. You can run this in two ways. Either click on a run button here or shift enter. That also will run. Yes, you can see values of the A and B before swapping is 10 and 20. Now, how do I swap this? There are different approaches for swapping. Let me start with the first approach. If I want to swap the value of A and B, that means say that A should become 20, B should become 10. One of the approach would be, I will define a temporary variable that is called as temp, and I will assign value of the A to that. Now, if you go ahead and say print temp, let me run this for you. Okay, value of the A is 10. So value of the temp is 10 now, because I assigned the value of A as a value of temp. So value of temp is also 10. Now what I will do is, I will say A is equal to B, means in a way I am assigning the value of B to A. So let us go ahead and run this again. Because I am printing only temp here, because I have assigned a value of A to temp. That is the reason value of temp is 10 now. Now I will do one more thing. What I will do is, I will say B is equal to temp now. Now let me repeat the same thing here. Instead of printing the value of temp here, I will cut that and print the value of temp here. Let us see what comes here now. So what am I getting? I am getting the value of temp is still 10 because I have assigned the A to temp and I assigned the value of B to A and I assigned the value of temp to 10. Now if I say print A, can you guess what would be the value of A now? Yes, you are guessing it right. So value of A would have become 20 because I'm assigning the value of B to A. Awesome, isn't it? Now all I have to do is I have to just go ahead and take this. Let me go ahead and paste it here. I will comment these two lines and I'll say value of the A and B after swapping. Let me run this program now. Yes, we successfully swapped the value of the numbers. So easy, right? Please do practice it. Now, I will show you how to approach the same thing if we were to take the input from the user. In this case, what am I doing? I'm just hard coding the values, right? If I want to take the input from the user, how do I do it? Very, very simple. I'll just go ahead and say Python program for swapping numbers by taking the input from users. Okay, that's all I'm trying to do. I'm going to maintain all the things same except that I'm getting the values from users. What do I do now? I'll just copy this here, paste it here. If I want to take the input from the user, what should I do? All I got to do is I will mention it as an input. That means to say that I am getting the value from the user. For that, I will say enter the first value for A. Then I'll copy this, enter the value for B. Okay, it is going to take the inputs from the user. Now, rest of the code remains same. All I'm doing here is taking the inputs from the user. So let me copy this whole code and paste it here, right? Let us go ahead and run this. What happens if I run this? It will ask for a input from the user. Enter the first value for A. So I'll say some 54. Enter the second value for B. I'll say some 78. After that, it runs values of the A and B before swapping is 54 and 78. Values of the A and B after swapping is 78 and 54. Awesome. We learned how to take the input from the user and swap those numbers. Let us do one more variation here. Instead of having a logic where we are defining a temporary variable and assigning the values to that, we can do in one more way. Let me demonstrate that for you. It is very, very simple. You would say, why you didn't tell me this earlier only? Because I wanted you to understand. All I will do is I'll copy this whole thing and paste it here. And I'll say I'll change this different logic. Different. Okay. What do I need to do here? I have to just change the logic. How do I do it? Let me go ahead and remove this. All I will do is A comma B is equal to B comma A. Are you crazy? Is it going to work? Yes, it is going to work. Let us go ahead and run this now. 23 and I will say 37. You can see it, right? It is as simple as this. Wonderful. We understood how to swap the numbers by writing a Python program. It is very simple. Go ahead and write this program without looking at the code. Wherever you are facing difficulty, start looking at the code and write the program. So what is Fibonacci series? Very simple. It is a type of series where each number is the sum of the two that precedes it. And it always starts with the 0 and 1. It is better to understand the Fibonacci series with an example. Let us say 0 and 1 are the two numbers which it starts with. Then how do we get the next number? So the first number is 0 and 1. We have the next number as 1. Then here the next number is 1 plus 1, that is 2. The next number is 3 because that is 1 plus 2. Like this, in the Fibonacci series, each number is the sum of two numbers which precedes it. The number is 2 here because the previous numbers are 1 and 1. When you add them together, it is 2. 3 because previous numbers are 2 and 1. Then what is the next number? You guessed it right. It is 5 because the previous numbers are 3 and 2. So the next number is 8 because previous numbers are 5 and 3. What is the next number? 13 because previous numbers are 5 and 8. So this is what Fibonacci series are. So until what are the range you specify, you have to go on calculating like this. So Fibonacci series is type of series where each number is a sum of previous two numbers. You can see it 0, 1, 1, 2, 3, 5, 8, 13 and so on. Then how do you write a Python program to compute it? Let us understand that. First thing is you need to have two values because you need to add two values here, right? Otherwise, how will you get the next number? So you need to have two variables. Then up to what number you want to print the Fibonacci series. So those are the two inputs what you need. You need to declare a couple of variables and you need to also have an input range. You may want to get it from the user. Then how do we approach it? There are two parts it here. One, we need to use for and we need to have a computation. We'll discuss this in detail. After that, you have to print the Fibonacci series within that range. So then what exactly is happening here and why are we doing this? We need two aspects here. One is iteration. The second one is computation. Why do we need iteration? That is because you need to go on computing the numbers in a Fibonacci series one by one. That is the reason you need a iteration. That iteration you can do through loops. Either you can use a for loop or a while loop. It is up to you, whichever you are comfortable. Then we need a computation also. What kind of a computation? Very simple computation. All I have to do is add the previous two numbers, right? I'll say v1 plus v2 is equal to total, right? So these are the two numbers. I need to iterate adding these two numbers until the range which is specified by a user. Let us see this in action. I want to write a program for a Fibonacci series. I am in a Jupyter notebook. I will open a new notebook with a Python 3 IPY kernel. There you go. So what do I need to do first to print the Fibonacci series? As we discussed, I need couple of variables. I'll say val1 is equal to 0. Okay. Val2 is equal to 1 because Fibonacci series are printed from 0. And also I would need one more variable to accept the user input. So I want that to be int. I'm typing it as a int. Then how do I accept the value from a user? All I have to do is say type input and provide some statement to prompt the user. Enter the nth term of the Fibonacci series. Done. So what do I need to do next? As we discussed, I need to iterate until the input given by the user. So let us say I will shift enter. I want 10 Fibonacci numbers, right? So what do I need to do is I need to iterate till I get 10 numbers in a Fibonacci series. How do I do it? I can use loops here. We can use either for loop or while loop. I'm using a for loop here. For I, because we need a initiator here. Okay. So I am initiating with I, which is a temporary variable within the for loop. And I'll say I in range. I will provide the range. I am providing the range from 2 to val 3. Why am I saying 2? Why am I saying val 3? 2 because I'm already printing these two variables by manually. Okay, which I'll show you later. Val 3 because I want the Fibonacci series as specified by the user. I want to compute till this point. This is my range. So I will go ahead and compute now. What is there as a part of the computation? I just need to total. Total is equal to val1 plus val2. And I will go ahead and print this total. Print total. But when you do this, what happens here? Let us check that. I have made a mistake here. What is the mistake? It is showing me syntax error expected colon. So after for, I have to mention a colon so that the next statements are within for loop. So let me run this. Okay. So what happens here? Let us say 10. It is printing 111. Why is it printing 111? Because the value of val1 and value of val2 is always 0 and 1, isn't it? That is the reason it is printing 111 8 times. But I need a 10th, right? So because it is computing the value from 2, because I have given a range as 2. So in order to fix that, I'll say print value 1, value 2. Let me run this again. I want values up to 10. Okay, I got 10 values now. Can see that there are 10 values. There are 10 values. But I am not getting my Fibonacci series again. What do I need to do? What you have to do is very, very simple thing. You can make the val1 as val2, and you can make val2 as total. Let us see if it works now or not. So let me run this again. There is an unexpected indent. How do I fix this? Remember, Python do not impose you to separate the code by having either a flower brace or any other braces. What you got to take care in the Python is giving a proper indentation. So I made a mistake where I just gave total print val at the same line as that of the for. It was giving a indentation error. I fixed it now. Let me run this again now. So I'll say 10 again. Awesome. We got all the 10 values of Fibonacci series starting from 0. Isn't it awesome? Wonderful. But I want to know how is it being computed. What I will do is let me show that to you in a systematic manner. I will go ahead and copy this code and I will do a couple of things here. First thing is I will do some modification here. I'll say the initial value val1 is this, and I'll copy this. And I will also print these two things in each iteration of the for loop. Then it will be easy for you to understand what is happening here. So I will say the print. Okay. So with this, we'll understand what is happening in each iteration of a for loop. Let me run this now. Okay. I will give the value as 10. Again, it is so easy to understand now. You can see the first thing is enter the n term of the Fibonacci series. We have provided as a 10. The initial value of val 1 is 0. Initial value of val 2 is 1. That means before we even start the for loop, value of val 1 is 0, value of val 2 is 1. So when we add these two, we got a total as 1. That is the first number. Then the number of val 1 becomes 1. How is that? Because we are assigning the value of val 2 to val 1. That is the reason it becomes 1. And what is the value of val 2? That is the total. Total is 1. So here the value of val 1 is 1. Value of val 2 is 1. And when we add them together, the total becomes 2. Then if you go to the next iteration, the value of val 1 will be 1. Then value of val 2 is the total, that is 2. Then 1 plus 2 is 3. This is how the iteration happens, and you will get all the values of Fibonacci series. Okay, so I will comment them, and I will just take out this. I'll comment this. Now let me run this program. I need to give the number 10. You will get the Fibonacci series starting from 0 until 34, because we wanted only 10 numbers starting from 0 till the nth term. Nth term is 10. That is the reason it is printing only 10 numbers as a part of the Fibonacci series. Don't you think sometimes users will do a mistake? They may give a 0. They may give a negative number. We need to tackle that as well, right? How do I tackle that? Any idea? What we need to do is we can use a if-else statement. Let me modify this code. I will just say if val 3 is less than or equal to 0, just print there's some message saying 0 or negative numbers are not allowed. What if he gives a negative number? That is also taken care of this. But in case if he gives a number as 1, what should I do? I need to print only those two numbers, right? So I will say else if val 3 is equal to 1, just print val 3 because he is giving only 1. Else you can print the other things. Okay, so let me run this now. So there is a problem here. Let me fix that. Okay, I fixed the indentation error again because for is a part of the else statement, right? That is the reason you have to align for after the else statement. Then now all these computations are part of the for loop. Let me run this now. Okay, it is asking me for a value. So what is that we are trying to do here? If you say 0, it would give us 0 or negative numbers are not allowed. So let me go ahead and run it again, and I'll say -1. Again, it will print me 0 or negative numbers are not allowed. Let me run this again, and I will say 1. So it will print only 1, right? So let us go ahead and give a correct value here. I will say 10 or rather 5. It will compute the values of a Fibonacci series, right? So we took care of if user enters 0 or negative numbers, then the program should prompt us to enter the correct number by saying 0 or negative numbers are not allowed. What is the factorial of a number? Pretty easy, right? You would have already studied this as a part of your high school, right? So what is the factorial of a number? Factorial of a number is the multiplication of all the numbers between 1 and the number itself. Let us take an example here. 5 factorial. How do we find that? All the numbers, the number itself. Here you can see 1 is there. And what are the numbers between 1 and 5? That is 4, 3, 2, 1. So what we'll do is we'll say 5 into 4, 4 into 3, 3 into 2, 2 into 1. So the factorial is the multiplication of all the numbers between 1 and the number itself. So 5 factorial would be 120. How do we write a Python program for this? Let us understand. As I always say, you have to have a thought process. You have to analyze how do you go about writing a program before you even write a program. The first and foremost thing is you have to accept a input. Means user wants to compute the factorial for which number. And second thing is after taking an input, there'll be condition. If the number is less than 0, if that happens to be true, then you have to say print the negative numbers not allowed. In case if it happens to be false, that means the number is greater than 0, and within that there'll be two possibilities. Number can be equivalent to 0. If that is true, then print the value greater than 0, or it will be equivalent to 1. Then if it is false, go ahead and compute the factorial. How do you compute the factorial of a number? Pretty easy. The computation involved here is all you have to do is whatever the number which is specified by a user, that number into all the numbers between 1 and that number. How will you do that? So we can do that by iterating through all the numbers between 1 and that number. How do we iterate? By using a loop that we have already done. There are two parts. One is iteration. Again, we can do that using a for loop. And the second one is computation. Computation is multiplying all the numbers between the input number and 1. After that, we'll get a factorial of a number. We can print that. So let us see this in action. I am in Jupyter Notebook. Let me go ahead and open a new notebook to write this program. You can see the title of this notebook is Untitled 8. Do you want that to be Untitled 8? No. Let us double click on that and it will open this box. Let us double click on that. It will prompt us to change the name. So I will say Python program for factorial. Damn. You can see that is what appears here. So what is the first step? We got to accept a input from a user. How do I do that? Very simple, right? First, declare the variable like val1 is equal to, I'll say int because I want to accept only the int numbers, and I'll say input, and I'll go and say, please enter the number to compute the factorial. Okay, then we got to have one more variable because that is needed for the computation, right? I'll say fact is equal to 1. I'm initializing it to 1 because all the factorials need to be computed from 1. Then I got to iterate it, right? So for that, I will use a loop, for loop, and I will say I in range, and I'll say 1. I want to start the range from 1 and also val 1. I am purposefully missing to give something here, but I'll tell you what it is. Okay. So let me go ahead and say now, what is the computation? Computation is, as we already discussed, fact is equal to fact into what? I, right? Because I want to iterate through all the values of I. I am starting I with 1, then I'll go up to val 1. So let me go ahead and print. I'll say the factorial of a number is fact. I'm going to print the same thing. Okay. Is the program ready? Let us go ahead and execute this. So I'll say shift enter. Oh, there is a problem here. Remember always, whenever you are having a loop or if else statement, you have to give a colon. That is the part of the syntax. Please do not forget this. From next time onwards, I'm not going to show this to you. So let me go ahead and run this program again. Again, there is an issue. It says, I forgot the comma. Okay, where? Here. Let me go ahead and fix that. I hope you guys are able to understand this. Will this work now? Let us see. Yes, it is working. Let me enter 3. What should be the factorial of a 3? It is 3 into 2 into 1. That should be 6. Will this compute the factorial correctly? Let us see. The factorial of a number 3 is 2. Is that right? No, it is not right. Then where exactly may be a problem? Can you think for a while? The problem is here. I did indicate to you, I am purposefully making some mistake here. If you see, I'm saying a range 1 up to val 1. How does the range function work? Until that value. Range function will not include that value. So if I want to compute the factorial until the value provided by a user, I want to provide a range as a val 1 plus 1. So that way it will include the number provided by the user. Let me go ahead and enter this and say 3 now. Yes, we fixed it. Let me take one more bigger number. Okay, let us say 5 here. It is 120. Yes, our program is working fine. But how exactly is the iteration going on? Very simple. What I need to do is I'll print the values before the computation. So let me go ahead and copy this and I will print the values before the computation. That will help us to know. I'll print fact and I will print. Why am I printing I? Because I want to know how the values are getting iterated, right? Okay. So one more thing I need to do is I got to bring this print also within the loop. Otherwise, there'll be an issue. I'll say for each of the i's, what is the correct? Let me see if it takes care of this. Let me enter this. Yes, say 3 now. Yes. Let me explain it again. I will say, how is it working? 1, 1. The value of the factorial is 1 before it is entering the loop, and the value of I is 1. And next, what happens is the computation has to happen. Then fact into I, that is 1 into 1 is 1. So the factorial of a number I is 1. For the first time, value of I is 1. Then the increment happens. The next one, what happens is still the value of the fact variable is 1, but the incremented value of I is 2. That is what is happening here. Then what happens is the factorial of a number 2, that is 2 into 1 becomes 2. Then at this point of time, the value of the factorial is 2. Then I is incremented to 3, right? Then what happens is the factorial of a number 3 is 6. Okay, we understood how iteration is happening and how the computation is happening. Is there anything missing in this program? What if user gives a negative number? That scenario we need to handle, right? So how do we handle that? Very simple. Let me copy this program and paste it in a different cell. So all I will do is I will introduce a if statement here. If value of 1 is less than 0, if user gives value of number less than 0, then say, Are Baba, please give a value which is a positive number. Or rather, I'll say, please enter the positive number. Okay. And I will bring this guy, say else, do this. Remember the indentation, right? Now all I have to do is to tap that. So one more thing I got to take care is, I'll say val1, because I don't want to iterate now. And I will go ahead and comment these two. Okay, I think we are all set. Let us go and test this program and give 5 array. I fixed one problem, but I introduced one more problem. Do you want the factorial of a number 5 is 1 to be printed like this? Actually, it is not correct. Again, I have to tackle this. How do I tackle this? Any thoughts from your side? Can you think of, I want to print only this one. How do I do that? Pretty simple. So what you can do is introduce a if statement. Then I say print only for the value of 5 when it hits the value of 1. Only in that case print this, otherwise it doesn't make sense. Let me take care of the indentation. Okay, let us run this again. I will say 5. Awesome, we fixed that also. Did you look at the ways how we get to different issues and how do you tackle them? Isn't it really good? Aren't you enjoying this? Please try all these variations and become good in Python. First of all, what is a prime number? Such a simple question, right? Prime number is a natural number that is greater than 1, which is divisible by 1 and itself. No other number will be able to divide this number. That is prime number. For example, we have 2, 3, 5, and so on. Let us say 7. Can any other number divide this? When you say divide, divide as a whole. Okay, so let us try. By 1, yes, it is divisible. By 7, yes, it is divisible. But how about 2? 2, 7. Okay, no, it is not. How about from 3? No. That way, it is a prime number. Then how do we approach writing a Python program for this? Let us understand that. To write a Python program, what is the logic? First thing is, we have to check if the number is divisible by any other numbers apart from 1 and itself. In this case, I'm taking a 7 as an example. So I need to check whether 7 is divisible by any numbers between 1 and 7. That is the first thing. So that is a computation. The computation part is, I need to check if the number provided by a user is divisible by any numbers between 1 and itself. And in order to do that, I need to iterate through all the numbers. How do you iterate? By using a loop. Let us get into an action now. So let me open a new notebook with Python 3. There you go. I will change the name of the program as a Python program for prime number. Name the way you want. Okay, what do I need to do first? I need to accept the input from the user. How do I do it? Very simple. I'll say val1 is equal to int. I want the value to be int. Then I'll say input and I'll say enter the number to check if it is a prime number. Okay, then what do I need to do next? I need to check whether the number is divisible by any of the numbers between 1 and itself. If it is divisible by any of the numbers between 1 and itself, then it is not a prime number. If it is not divisible, then it is a prime number. All right, so for that, I will use a for loop for I in range, and I will start with the 2. That is because we don't want the number to be divided by 1. We already know that it is anyway divisible by 1. And I will say until what? Until val1. Then how do I check whether the number is divisible by any of the numbers between 1 and itself? We have an excellent operator called modulus, right? We can use that here. How do I use that? I'll say if the val1 modulus I, because I'm getting the value from I, this loop, is equal to 0, then I have to say print it is not a prime number. Then I'll say else print it is a prime number. It should work, right? Let us try that if it works or not. Okay. So don't assume something until we complete this video. Please follow with us to understand what is the approach to find whether the given number is prime or not. So let me enter this. Okay, I will say 5. It is a prime number, it is a prime number, it is a prime number. It is giving the result 3 times. Let us give some other number. Okay, that is like 4. It is not a primer, it is a prime number. What do I need to do here? When I give a prime number, it is printing me 3 times it is a prime number, it is a prime number. When I am giving a non-prime number, it says it is a not prime number and it is a prime number. Why is it happening? So how do I fix this? And what is happening here? If you observe carefully, when the number is prime number, It is printing 3 times because else is within the for loop. So it is going through as many iterations as number of values between the 2 and 5 in this case. If I give some other value, let us say 10. If you see what is happening is it says it is not a prime number and it is printing as many times as possible between the 2 and the number itself. In order to fix this, we have to move the else outside the for loop. How do I do it? Very simple. Bring the else at the same level as that of a for. Let us see if it works or not. Anyway, otherwise we'll fix it. Yes, it is working. If I give 5 here, awesome. It is printing only once. Does that mean all the things are fixed now? Not really. So what is that not fixed? Let us give number which is not a prime. Okay, what is this? It is saying it is not a prime number and it is saying it is a prime number also. What essentially happening here is when you give a number which is not a prime number, it will get identified at this level. When if val modulus I is equal to 0, then it is not a prime number. But then what happens is the else statement is at the same level of for. After this gets executed, else also will get executed. So in order to prevent the else statement to be executed, if we find a number to be not a prime number, we can introduce a break statement here, right? Okay, let us see if it works or not. Let me enter this. Okay, if I say 4, wonderful. We fixed this as well. Is that all? Do we need to do anything else here? Let us understand how it is iterating through by introducing couple of print statements. Let me introduce couple of print statements here. So I will say print the quotient. I am saying the quotient of val1, that is a number given by the user, divided by I, that is a number from a for loop here, right? And I'm getting a quotient how? By dividing the number given by the user and the range of values between 1 and that number itself. Okay, and I'll copy the same thing here and I will say the reminder val1 is val1 modulus I. Okay, let us understand this. So I introduced these two statements. The first statement says the quotient of val1 is how much and the remainder of val1 modulus I is how much. Okay, so by executing these statements, we'll be able to better understand this. Let me execute this. Okay, for the first time, the value of I is 2 and the number given by the user is 5. So I am dividing 5 by 2 and the quotient is 2.5. And the 5 modulus 2, the remainder is 1. That means to say that for the value 2, this condition is not passed. Now, once it checks for 2, it will move to the next number in the for loop, that is 3. Again, it will check for a 3. 5 by 3 is 1.66. 5 modulus 3 is 2. So that means say that this is also not matching this condition. And after that, it will go to the next number in the loop, that is 4. Then I'll say 5 by 4 is 1.25. 5 modulus 4 is 1. Again, this condition is not satisfied. So it will come out of this and then gets into this else statement. So it prints it is a prime number. Wonderful, isn't it? We understood how it is iterating through the different numbers in a for loop. Are we missing anything further? What if the user gives 0 or 1? How do we tackle that? So all we got to do is we have to introduce a if statement before the for statement. Okay, so I will do that now. The way I will do it is, if val1 is less than or equal to 1, say print provide value more than 1. Let us see what happens here. Are we missing anything here? Yes, we are. We also need to provide the else statement, right? When we have a if, at least in this case, we have to provide the else statement. Now, what I will do is, I will go ahead and align this under else statement. Let us go ahead and execute this. Okay, let me check for the one. It says provide the value more than 1. Let me go ahead and check for a 0. It says, and let me execute this further and say 5. Awesome. We fixed everything. In order to get the exact output, let me comment this and run this again. I'll execute this. I'll say 5. It is a prime number. And let me check with some other number. Let's say 8. It is not a prime. What is an anagram? Very simple. Anagram is a word or a phrase formed by rearranging the letters of a different word or a phrase. Just to take an example here, let us say you have Ram. I can rearrange that as a arm. So these two are anagrams. If we have to check given strings are anagram or not, it has to satisfy two conditions. One is both the strings, the string 1 and string 2, should be of same length. Length should be same. Means number of characters in one string is same as that of another string. And the second condition is both the strings should have same characters. Means here the sequence in which the characters are arranged may be different, but they should have a same character. So how do we approach writing a Python program to check whether the strings are anagram or not? Let me take an example. Let us say we have a first string as rat and second thing as tar. Both of them are anagram. If I were to write a Python program for this, how do we approach it? First thing is we have to accept couple of inputs from the user. That is anyway need to be done. Second thing is there any iteration involved here? Maybe or may not be. If you want to take a long route, then use the iteration. If you want to do it in a very simple and concise manner, you can take help of inbuilt functions of Python. And do we have any computation involved here? Not really, because we are dealing with the strings. It doesn't make sense to do any computation on the strings. So iteration may be involved, but that may not be required. Let us get straight to the Jupyter notebook and start writing a program for this. Okay, I have opened a Jupyter notebook. So first and foremost thing is we got to accept the two strings. For that, I will declare the variable as val1 and I will say str because I want to accept only the string values. I'll say input please. Okay, and I will say please enter second string. And I'll change this from val1 to val2. Okay, so what did I say? I need not use the iteration here because we can get this done with a very simple and straightforward function that happens to be sorted. So what I will do is I will say if and I'll say sorted val1. What am I doing here? I'm sorting the characters of a first string and checking whether that is equivalent to the sorted characters of 2. If both of them match, then it is an anagram. If they don't match, then it is not an anagram. So if this matches, I will say print given strings anagram. Else they are not. I'll copy this and paste it here. Shall we take an input and see? Let us do that. There is an issue here. I'll fix that. Okay. Now our program is working. Let us check this. I'll say rat and tar. The given strings are anagram. Just to make this program a bit more explicit, what we'll do is we will print the sorted strings to check whether they are correct or not. I'll say I'll take this. Okay, I'll copy the same thing here. I'll say not rat and tar. Okay, you can see the given strings are anagram. You can see first rat is arranged in alphabetical order, ART. Then tar is also arranged in alphabetical order, ART. Then both of them are compared, and if they are same in terms of number of characters and also the same characters, then they are anagram. Let us check for one more value. I will say Jaya, then Arun. The given strings are not anagram because it say Aja, Andrew, right? They are not anagrams. We can also do one more thing. Instead of printing these things, I will copy this, and instead of sorting the values here, I will sort the values initially only before I compare them. I'll say is equal to here. Say it as a, then I'll give a B here. Okay, here instead of directly sorting the values while comparing, I will sort the values, store that in a variable, and use those variables for comparison. Let's do this. Okay, I'll say tar and I'll say rat. What is palindrome? Palindrome is a word or a phrase or numbers or any sequence of symbols that reads the same backwards as forwards. Is it confusing? It is best understood by an example. Let us take an example here. Madam. If you reverse it, it sounds same and the sequence of characters are also same. You can see it, right? Can you think of any other palindromes? There you go. We have 101, right? It's the same thing. I'm saying here for the numbers, and you can take an example of symbols also. For example, at the rate, dollar at the rate is same when you reverse it also. Any other examples? Mom, right? It sounds same, and also the characters are also same. So if we want to write a Python program to check whether the given input is a palindrome or not, what should be our approach? So first thing is we are accepting a input. That is anyway very simple. The second thing is first we have to reverse the input. Then compare the value of reverse with the input. For example, you have an input and compare that with the reverse of input, and if both of them are same, then it is a palindrome. If they are not same, then it is not a palindrome. Let us see this in action. Okay, first thing is we have to accept a input. I'll say val1 is equal to input, and I'll say enter the value to check if it is say palindrome. Okay, then after that, what did I say? I have to reverse it. I will just create one more variable to store the reverse. I'll say val1 dot reverse. Stay with me, don't jump into some conclusion. I'll say val1 dot reverse, right? So if val1 is equal to reverse 1, then I will say print val1 is a palindrome. Else copy this. Okay, Will this work? Let us check whether it will work or not. Let me go ahead and run this. I'll say mom. It says string object has no attribute called reverse. So reverse would do the job only in case of lists and arrays. So what should we do here now? There is a wonderful option for slicing. We'll use that. It is very simple, yet will do the job. So what I will do is I will say val1 and open a square brace or square brackets. And then I will say -1, then double colon and -1. What essentially happening here is -1 means we have to start reversing from first character from the end of the string. And then we have to provide a last character here. But we are not providing here because we want to ensure that the whole string gets reversed. And -1 means it is an increment. You have to go on incrementing by -1. As a part of the slicing, what we need to provide is from which character you want to start reversing. -1 means start reversing from the last character of a string. Then between these two colons, we got to provide the end of reversing. We are not providing because we want to reverse the whole string. And this -1 indicates incrementing of the reversal. Whether you want to go one by one or you want to skip. In this case, we want to go one by one. Wonderful. Let us go ahead and execute this. Okay. I'll say mom. Yes, mom is a palindrome. Let us check one more thing. Let us say cat. Cat is not a palindrome. Now let me check one more thing. Mom is a palindrome, right? Yes, it is. Let me see whether it is working or not. What is happening here? It says mom is not a palindrome. Hey, why is it not working here? Because there are uppercase letters here. Let me remove the uppercase letter and check this. Mom, it says mom is a palindrome. So how do we tackle this? User may give uppercase letter also, right? Let us tackle that. Okay. So I'll just copy this and paste it here. And what I will do is I will use a function called upper, and I'll do the same thing with the also. So essentially, I'm converting all the letters of input to upper and all the letters of reverse also to uppercase. We run now, and if I say mom, wonderful. It says mom is a palindrome, even though I am giving uppercase letters as a part of the input. What is an array? Array is nothing but a homogeneous collection of data. What do you mean by homogeneous? Homogeneous means same kind of data. Or we can also say a collection of data with the same data type. For example, here we have an array named A with numbers. Okay. When I say homogeneous, you can have only numbers here. I cannot have an array which is saying 10, then J, then Arun, like that. This is not possible because array is a homogeneous collection of the data. If you want to insert elements into array, you need to understand what is insertion. So what is insertion? Insertion is nothing but inserting an element into an array or list. So let us say you have an array with 1, 2, 3. If you want to insert 4 at the end of the array or in the middle of the array, then you have to use insertion methods. In Python, we have 3 insertion methods. One is append, second one is extend, third one is insert. What is an append? Very, very simple. Append is an array method used for appending or adding the elements to end of the array or list. So here we have an array with elements 1, 2, 3, 4, 5. If you want to add element 6 to the end of the array, we can go ahead and say array that append and mention the element you want to append. Then the appended array will have 6 in their list. Wonderful. Let us see this in action in Jupyter Notebook. What do we need to do now? So what I will do is I will go ahead and define one array. Okay, I'll say array1 is equal to, I'll go ahead and type 10, 20, 34, 56, then 66. Okay, this is my array. So what is the requirement here? I want to append new element to the end of an array. For that, let us accept that from a user. I'll say val1 is equal to, I want this to be int because this array is of elements with a int data type. So I'll say int, then I'll say input, enter the value to be inserted into an array. After that, all we have to do is use a append method. I'll say array1 dot append and provide the value to be appended here. That's it. Then let me print this array before and after. Okay, let us enter this. I say I want to enter H9. You can see before the value is inserted, elements in an array are 10, 20, 34, 56, and 66. And once we use an append method and insert an element provided by the user, it has added 89 as a last element in an array. That is the reason it is called as a appending. Let us say we have one requirement. The requirement is you want to add series of elements into the array. How do you do it? Let's say I will do it here and I'll say array 2 is equal to, I'll say 89, 58. Okay, and I will comment this guy and I'll say instead of array 1, I'll say array 2. Okay, let us see what happens here. Did you observe what is happening here? You can see elements are added, but they are also considered as a array. It's like a array within an array. I don't want this. So then what do you want? I want 89 and 58 to be added as a part of the elements of array 1. Then how do I do it? For that, we have a wonderful method called extend. So extend is a array method that adds each element of the iterable to the end of the array. Means if you see, you have an array with elements 1, 2, 3, 4, and 5. We have an array with element 6, 7, 8, 9, and 10. If you use an extend method and provide the array as a part of the argument, then it will properly insert the elements of array into the array 1. Let us see this in action. So all I will do here is I will go ahead and use the extend instead of append. Let us see what happens here. You can see 89 and 58 are appended to the end of an array. Wonderful. We understood how to append, how to extend. What if I want to add a specific element at a specific place? Then append and extend wouldn't do the job. That is where insert comes into picture. So insert is a array method that inserts a given element at a given index or position in a list. Let us say array is having 10 to 50 elements. If you want to add element 35 at position 3, you need to understand how the indexing works here in order to understand this. The way indexing works in array is when you have an element, the first element is indexed at 0, second element is 1, so on and so forth. So index is 0, 1, 2, 3, 4. If you want to insert an element as a fourth element, then you have to specify the position as 3 because index 3 denotes fourth element. Now, if I go ahead and use insert, this specifies the position and this specify the element. Python would insert 35 at third position, which is fourth element in an array. Let us see this in action. Let me copy this. What I will do is I'll repurpose this program, say val1, and I'll say enter the position at which the value to be inserted into an array. And I'll rename this guy as val2. So what do I need to do now? I need to use a method called insert. How do I use that? Very simple. I will take off this and say insert. I need to provide two arguments here. One is the position at which the value to be inserted and what value need to be inserted. There you go. Done. Let me run this program for you. If I say the position is 3 and the element to be inserted is 10,000. You can say at position 3, that is fourth element in an array is added with 10,000. What if user provides a position which is beyond the length of an array? Let us see what happens here. I'll say enter the position at which I'll say some 10 and I'll say 10,000 again. It is getting inserted at the 0, 1, 2, 3, 4, fifth position. Do you wanted it to be inserted at fifth position? No, you wanted it to be inserted at 10. But the problem here is length of the array itself is 5. In that case, one of the way taking care of this is getting the length of an array and see the input user giving is within that length. So what I will do is I will go ahead and get the position here. Okay, I'll say position is equal to length array 1. Then I will print the position so that you know what is the length. So I will only check whether user is giving the position which is less than or equal to the length of the array. How do I do that? I'll say if val1 greater than pass, that is the length of an array, I'll say print enter the value within the length of an array. Okay, and then I will go and insert else do this. So in case the user is providing position beyond the length of the array, the program comes out. I'll say there is a problem here. It is an indentation error. You need to position these three things. Okay. So let us say in this case, length of an array is 5. Position is different from the length of an array. So here we say 5. If I provide a value which is more than this, then it will tell me enter the value within the length of an array. This is how you take care if the user provides a position beyond the length of an array. If I say now 4 and I'll say 1000 to properly insert. Wonderful. We learned how to insert an element at a certain position in an array. By the way, what is deletion? Deletion is nothing but a process of removing an element from an array or linked list. In one of our previous video, we understood how to add elements into the array. It is not always we keep adding the elements into array, right? There is a situation where we have to delete an element from an array. In Python, we do have different methods to delete an element from an array. One is remove. The second one is delete. The third one is pop. And the fourth one is clear. What does remove do? Very simple. Remove function deletes the specified element. And whenever a particular element is repeated twice, then it deletes the first instance of the value in a list. Let us take an example here. So you have an array here with some elements 10 to 50, 10 is repeated. When you say array dot remove 10, it removes the first element, which is repeated element. Okay. And one very important aspect here is it deletes the element regardless of the index. We are using remove to delete an element from an array. It doesn't matter that element is in which index of an array. We have del array, del, del keyword removes the specified index. Remove removes the element, but in del we have to specify the index of an element which we have to remove. So it can also delete the list completely. If you want to wipe out the whole array, you can use the delete. See here, array, we have an array where we have some 5 elements 1, 2, 3, 4, and 5. As we already understood, the elements, the indexing is starting from 0. That means first element is there in the index 0 and fifth element is there in the index 4. Remember, del keyword removes the specified index, right? In this case, if I say del array 4, it is going to remove 50, which is a element in the index 4. And if you want to delete the whole array, just say delete array. It will delete the whole array for you. Then we have a function called pop. What does it do? It is used to remove the specified index. It's almost like a del. If you don't specify an index, then it deletes the last element of an array, which is not there in case of del. Let us take an example here. We have 10, 20, 30, 40, 50. And if you say pop 1, it will delete this particular number. And the result will be 10, 30, 40, 50. And if you are not specifying any index, it will delete the last element of an array. One more option is clear. Clear is a function to empty the elements in an array. So you want to keep the array intact, but if you want to remove the elements, then you can use the clear function. We have an array. If you say array.clear, it will remove all the elements of that array. Let us see all these functions as a part of the hands-on. So I have opened an Jupyter notebook. Let me go ahead and define an array here. So I'll define an array. Array is equal to, you can define an array with square braces. I'll say 10, comma 10, comma 20, 30, 40, and 50. So I'm going to use a remove function here. The way I do it is array dot remove and specify the element which you want to remove. Let us say in this case, I'll remove 20. And if you go ahead and say print array, you'll get to know. Let's say print before remove, print after remove. Let us see how it works. You can see the element 20 is removed from the array. What if I say remove 10 for me? What will happen here? Let us see that. 10. You can see it removes only 110 out of this array. Okay, this is a remove box. The next function is delete. So I will repurpose the same thing. I will do one thing. I will comment this. Let me say del. So as we already discussed, del works based on the index. If I have to remove 20, I have to specify del array 2 because 20 is there in the index 2. This is 0, 1, and 2. Let me go ahead and say 2 and move this print after this. So it is giving me an invalid syntax. That is because I made a mistake here. I have to say del, the small del. Okay. Now if I go and say, it works fine. So if you want to delete the whole array, all I have to do is say delete array. Let us see how it works. Tell array. Array is not there because here you can see it has deleted the array. Okay. So this is how you use delete. Now what I will do is I'll say print array, should print it twice. Okay. So the next function is pop. Pop also removes the elements based on the index. Let us say if I say pop array dot pop 1. If I say pop 1, it is deleting the second element based on the index because first element is there in the index 0. Second element is there in the index 1. So let us try one more here. If I say, you can see it has deleted 20. Okay. Let us say if you are not specifying anything, then what it does is it removes the last element. You can see 50 is gone here. So this is one of the important function to delete the elements of an array. The last function is clear. I want to keep the array intact, but I want to remove the elements of an array. How do I do it? Very, very simple. I'll say array clear. And if I print, there are no elements in an array after array.clear function is executed.
That's all for now. Like and subscribe and turn on notifications for future videos. Thank you.